Hello my dear students, welcome to IMS Gate Academy Gate Score Booster series of network theory subject. So in the previous session we have discussed the questions regarding the first chapter regarding the basics of network theory, that is regarding nodal analysis, mesh analysis, source transformation. We have discussed variety of questions, and then regarding network theorems also we have discussed one question regarding superposition theorem. After that I have given one question based on maximum power transfer theorem as a homework, right? So how many of you have tried that question? Whoever tried by this time, you can mention your answer in the chat. Okay. So whoever not yet tried, no issue at all. In this particular session, I will show that question as the first one. Okay. I will give some time for all of you, right? So after that, we'll discuss the remaining questions from the remaining chapters. Okay. Right. So this particular session is common. This subject is common for three branches: EC, electrical and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session, right? So I hope all of you got lot of knowledge and how to solve the network theory questions in less time, right? Whatever the shortcuts we have discussed in the last chapter, last session, right? Similarly, in this particular session, we are going to discuss some more interesting questions. All of you will get good variety of concepts, okay, how to solve the network theory questions in less time, okay, right? So I hope all of you are eagerly waiting for the session. So let us start. So this is the question I have given as a homework in the last class, okay. Whoever tried by this time, you can mention the answer in the chat. Whoever seeing this particular session very first time, okay, no issue at all. Now I am going to give some time, okay, so all of you can give it a try. So this question is of MSQ, right? So either one option or more than one option can be correct. This question is based on maximum power transfer theorem. In this particular question, you're having one circuit diagram, right? Here you're having the load resistor RL. Now the question is, in order to get maximum power across this particular resistor, right, you have to find out regarding the RL value and what is the maximum power that you are going to get across the load resistor. So regarding RL value, you're having two choices. Regarding maximum power across the load resistor, you're having two choices. So among these two choices, at max one option can be correct, and similarly among these two choices, at max one option can be correct. All of you give it a try. At least some of you can try to find out among option A and option B which one can be correct. Okay, other students can try among option C and option D which one can be correct. Yeah, time up. Okay, whatever the answer you are getting after solving this question, you can mention in the chat. So, whenever you are solving any question regarding maximum power transfer, right? So just identify the given circuit. In the given circuit, what kind of sources you are having? First of all, you have to observe. In this entire circuit, you are having two sources, right? One is voltage source. Here you are having 10 volt, and it is independent source. Okay. Similarly, here you are having 2i. You are having the value. You are having 2i. But whether it is voltage source or current source, just by observing the polarities, whenever you are having voltage polarities like plus minus, that means it is a voltage source. Okay. But here you are having the value 2i. Here I indicates what? Current. Okay. In this particular circuit, you are having I here. That means the current flowing through 6 ohm resistor is nothing but I. That value, if you are multiplying with 2, you are getting the voltage value of this particular source you are getting, right? So that means it is a voltage source, but it depends on other parameter or other variable, that is the current. So that means it is current controlled voltage source. Okay, whereas here it is independent voltage source, whereas it is a dependent voltage source, right? In this way, whenever you are having dependent sources, okay, don't get confusion just by observing the value here. Okay, or just by observing the expression here. Okay, whether you are having in terms of current or in terms of voltage, irrespective of that, the moment if you are having polarities plus minus, that means it is voltage source. If you are having arrow direction, that means it is a current source, like that. Okay, so in this case you are having one independent source, one dependent source. Okay, right. And in this particular circuit, whatever the sources here you are having, because independent source you are having DC source, right? So that means this particular circuit is nothing but DC circuit. Okay. So now we are going to solve regarding, in order to find the RL value, in order to get maximum power across it. Okay. We are using maximum power transfer theorem, but currently we are considering the circuit DC circuit, right? After some time, I will discuss based on maximum power transfer theorem. We will discuss one more question when we are having the sources AC. Okay. So currently we are discussing the maximum power transfer theorem with the help of DC circuit. Okay, right. I hope all of you know the condition. See, whenever you are using maximum power transfer theorem, so first of all, whatever the load resistor here you are having, first of all we have to remove the load resistor. Then the moment if you have removed the load resistor, here the terminals will become open. Terminals will become open. The moment if terminals are open, then across the open circuit terminals, you can find the voltage. That is nothing but Thevenin's equivalent voltage or open circuit voltage, right? And then across the open circuit terminals, you can calculate the RTH. So that means whatever the circuit or network you are having, after removing load resistor, you are finding the Thevenin's equivalent circuit, right? That is the first step. So first of all, you are finding the Thevenin's equivalent circuit. So that means VTH and RTH. Right? You are finding VTH and RTH. After that, in order to get maximum power across the load resistor, so the condition is what? RL should be equal to, all of you can answer. I hope by this time all of you are familiar. In order to get maximum power across the load resistor, what is the condition? RL should be equal to. And once if you calculate RL, after that we can calculate maximum power across the load resistor RL. Maximum power across the load resistor RL. So in this question, I have mentioned as PL max. Okay. So that PL max is nothing but the maximum power across the load resistor. See, RL is nothing but RTH. RL is nothing but RTH and PL max. So in this question, I have labeled as PL max. Both are same. So which is nothing but VTH square divided by 4 times RTH. VTH square divided by 4 times RTH. Right. So now in the question, 2 options you are having regarding RL, 2 options you are having regarding PL max. Right. So if you observe both the equations, in both the equations you are having one of the term as RTH. you're having one of the term as RTH. Okay, and of course in this particular equation, in addition to RTH, you're having VTH. Okay, so first of all, let us calculate RTH. After that, we'll calculate VTH. Okay, right. So first of all, let us calculate RTH. Okay, so first I am explaining regarding RTH with the help of one method. Later I will discuss one more method. Okay. So regarding RTH, whenever in the circuit, okay, say for example, the moment you have removed the load resistor, then terminals become open. Across the open circuit terminals, if you are having the entire network, if you are having only resistors, and in addition to the resistors, if you are having only independent sources like voltage sources, current sources, then we can find directly the equivalent resistance by making voltage sources as short circuit and current sources as open circuit, right? Then the rest of the network, simply you are having resistors in the combination of series, parallel, or star, delta, whatever it may be. Okay, you can find the equivalent resistance. But in this circuit, okay, along with independent source, you are having dependent source. Okay, you can make voltage source as short. But what about this dependent source? Dependent source we cannot make directly like short or open. Okay, unless otherwise based on this particular dependent value. Based on this particular here I value. Suppose if I value is 0, then when you are substituting here, 2I value becomes 0. Because of that, we can make voltage source as short. But if I value is not equal 0, in that case, we should not directly make it as short. Okay. So that means in that case, we cannot find directly the equivalent resistance. In those cases, what we can do, first of all, you can find the open circuited voltage. After that, you can find the short circuited current and then take the ratio of both. From there, you will get RTH. Okay, so that is the first method. So in the first method, we are calculating VTH first and then short circuited current we are calculating. After that, we are taking the ratio of both. From there, we will get RTH. Okay, so first let us calculate RTH in this method. Okay. So first of all, VTH calculation. Here load resistor we have removed from the circuit, then terminals become open. So across the open circuit terminals we are calculating the voltage. That is nothing but open circuited voltage or Thevenin's equivalent voltage, both are same. Okay. Now in this case, the moment you have removed the load resistor, across these two terminals you are supposed to find the voltage. Now in this particular circuit, this voltage is nothing but the voltage across this particular 6 ohm resistor. The voltage across 6 ohm resistor. Yes or no? Because this point, both are same. Okay, it is shorted, right? Same. Similarly, this point and this point both are same. So that means between these 2 points, voltage is same as across this 6 ohm resistor. Whatever the voltage you are getting, both are same. Now, the moment you have removed the load resistor from the circuit, terminals become open. So that means there is no current flowing in this branch. Similarly, there is no current flowing in this branch. Right. The moment if there is no current flowing in this branch, now whatever the current flowing in this particular branch is same as the current entering to this particular node. Yes or no? See, whatever the current enters to this particular node, since there is no current flowing in this particular branch, the entire current is flowing like this, and in this branch there is no current. The same current is flowing like this. In this way, the current I is flowing in this particular closed path. I hope all of you are getting. Right. Now, by using Ohm's law, you know the current, you know the resistor. Can we calculate the voltage across 6 ohm resistor? So all of you can respond. Yes, we can directly find, because we know the current, we know the resistor value. By using Ohm's law, across 6 ohm resistor, the voltage is nothing but 6 into I. Right. So as of now, what we got, since VTH and 6I both are same, right? The voltage across these two terminals is same as voltage across 6 ohm resistor. So that means VTH equal to 6I. I hope all of you are getting the clarity. Now somehow or other, if you are able to calculate I value, after that if you are multiplying with 6, from there you will get VTH for this particular question. Okay. Now we have to calculate I value. Okay. So for that, if you want, you can apply KVL around this loop. Okay. Or Whatever the shortcuts earlier class I have mentioned, okay, let us follow the same shortcut. Okay, so just observe here you're having voltage source, here also you're having voltage source, here you're having resistor, and here you're having current. So first of all I am writing the corresponding voltage across 4 ohm resistor, 4 into I. Okay, so if you want you can apply KVL around this loop like this, either clockwise or anti-clockwise, your wish. But for the time being, in order to find that particular I value easily, I am giving one more approach. Okay, so here just observe left hand side. So that means between these 2 points, we are having 10 volt source. Okay, between these 2 points we are having 10 volt source. So this is one path. Now whatever the other element voltages we are having, now I am placing vertically on the other side. Say for example, here you are having voltage value 2I, polarities are minus plus. For the time being I am bringing this horizontal branch into vertical. The moment if I bring this horizontal branch into vertical, then polarities will become minus plus, like this you will get 2I. I hope all of you are getting the clarity. Here minus plus is there. When you are placing vertically this element, you will get polarities like this, minus plus, and voltage value is 2I. And similarly here, plus minus 4I. And here you are having shunt branch. Okay, so regarding the 6 ohm resistor, just now we got voltage 6I. Okay, I hope all of you are getting the clarity. Now just observe, regarding these two, here plus minus, same polarities. Whenever same polarities are there, we can add the voltages. 4I plus 6I, that is nothing but 10I. But now, regarding this one, you are having voltage polarities opposite. Here plus minus, here minus plus. Now what we have to do? Whenever polarities are opposite, we have to subtract. Okay, so here 2I is smaller, so we can subtract 2I from 10I. And we will give polarities of larger number. Okay, so that means overall polarities you are going to get plus minus. So 10I minus 2I, which is nothing but 8I. Now, if you carefully observe, between these two terminals, in one branch, with respect to this branch, you are having 10 volt source, and with respect to rest of remaining elements, I have considered another branch exactly in parallel. From there, I am getting 8I. So whenever two branches are considered in parallel, obviously in parallel, which quantity should be same? Obviously voltage, right? In parallel, voltage will be same, right? So with respect to this branch, you are getting 10 volt. With respect to remaining branches, okay? So you are getting 8I. So these two are exactly in parallel. So in parallel, voltage should be same. So 10 equal to 8I. Right? So here 2 5s are 10, 2 4s are 8. So from here we can write I equal to 5/4, units are ampere. Since I is the current, units are ampere. Right? Now we got I value. 5/4 amperes. Now our requirement is to calculate VTH. VTH is nothing but 6 into I. That implies VTH equal to 6 into I value, just substitute here 5/4. Here 4, 1.5 times 4 into 1.5 is nothing but 6. So 1.5 into 5 is nothing but 7.5. Units are volts. VTH equal to 7.5 volts. VTH equal to 7.5 volts. Okay, I hope all of you are getting the clarity. How to calculate VTH across the open circuit terminals. Okay, right. So we got the VTH value. Now the next step is we have to calculate how much current is flowing through the short circuited terminals, right? Now let us short these two terminals. So in the short circuit terminals, how much current is flowing? Now let us calculate. Okay. So here these 2 points are shorted. Okay, so that means in general we'll consider See, the moment if these 2 points are shorted, now can you find how much voltage you are having across this 6 ohm resistor? And how much current is flowing in this particular branch? Whoever having basic knowledge, okay, you can easily answer, you can mention the correct answers. Here, end-to-end voltages are same. This point, both are same. Okay, so what is the voltage here you are considering? Same voltage here. That means the voltage difference you are going to get 0 volt. By using Ohm's law, 0 by 6 ohm, you are getting 0 ampere. I hope all of you are getting the clarity. Okay, right. So in this case, I value you got 0 ampere. I value got 0 ampere. Now, here you are having dependent voltage source. Okay, I value just now you got 0. So 2I, here in place of I, you can put 0. So 2 into 0, you are getting 0. 2 into 0 is nothing but 0. But now, this is voltage source. This is voltage source. Whenever you are having voltage source, okay, here you are having polarities minus plus, and the voltage value just now you got 0 volts. Okay, whenever voltage source value 0, that means it is short circuit. It is short circuit. Okay, or the across that particular element voltage value is 0. You can represent like this, or if you want, you can represent like short circuit. Right. Now, since in this branch there is no current flowing, okay, now if you apply KCL at this particular node, okay, from this node in this branch short circuit current is flowing, so that means the same short circuit current should flow like this, correct? Same short circuit current should flow like this. Okay, yes or no? Otherwise, here just now I have mentioned this point both are same. Okay, so that means from this point to this point, you are having node voltage as 10 volts. Between these 2 points, you are having voltage as 10 volts. Okay, this point, all are same. All the nodes are same. Okay, and in fact, all the nodes are shorted to this particular node, right? Correct? Now, here there is no voltage, or we can say 0 volt. Here also 0 volt. Now, can you say across 4 ohm resistor how much voltage you are having? Across 4 ohm resistor, how much voltage you are having? See, just like earlier concept. Here, I am having plus minus 10 volt. Plus minus 10 volt. Between these 2 points, I am having one voltage value 10. Okay. Consider other way. Here, 0 volt. Okay. Anyway, you can ignore. Here also 0 volt. You can ignore. Now here you are having simply 4 ohm resistor. That is connected between this point and this point. So directly you can say that across 4 ohm resistor, you are having same voltage. Across 4 ohm resistor, you are having same voltage, that is 10 volt. Because here voltage drop is 0, here also voltage drop is 0, right? And in this entire closed path, you are having only one supply and only one absorbing element or passive element. So what is supply voltage there? The entire supply voltage you are going to get across the resistor, right? So entire 10 volt you got across 4 ohm resistor. Now, as I have already mentioned, here, since there is no current flowing in this particular branch, whatever the current is leaving in this particular branch from this node, the same current should enter here. Okay, so that means by using Ohm's law, you are going to get here 4 into IISc. Right, now we can equate both. So that means 4 into IISc is equal to 10. From here you are going to get short circuit current as 10 by 4, which is nothing but 2.5 amperes. 2.5 amperes. Right. So we got VTH value as 7.5 volts and short circuit current we got 2.5 amperes. Now if you are taking ratio of both, from there you will get RTH. So now I am writing RTH value, which is nothing but VTH divided by short circuit current. So VTH we got 7.5. Short circuit current we got 2.5. So that means we are getting 3 ohms. RTH value we got 3 ohms. Right. So we already mentioned, in order to get maximum power across the load ratio, the condition is RL value should be equal to RTH. So just now we got its value is 3 ohm. 3 ohm. Right. So with this understanding, among the given 4 choices, as of now we can choose one of the option, that is option B. Option B is correct. Okay. Now since we got RL value and since we got VTH, for the timing let us calculate PL max also. After that I will discuss regarding RTH calculation in another method also. So PL max is equal to VTH square divided by 4 times RTH. VTH square divided by 4 times RTH. And just now we got VTH value as 7.5. You can substitute here. Divide by 4 into RTH value we got 3 ohms. So all of you do the simplification and tell me how much value you are going to get. How much you are going to get? See, all of you can use calculator, right? Or if you want, you can use mobile also. Yeah, I hope all of you are getting 4.6875. 4.6875 watts. Okay. So regarding this also you are having in one of the given choices. Yes, we are having in option C. So for this question, 2 choices are correct, option B and option C. Option B and option C. Okay, since we already calculated VTH value, so since VTH and RTH both are there, so I calculated both the parameters. Okay, so regarding RL we got, and similarly regarding PL max we got. But in sometimes, in some questions in the GATE exam, they will ask only RL value. Okay, so that time you can find whatever the method just now we have discussed, like first you can calculate VTH, then short circuit current, after that you can take the ratio. That is one method. Okay, now I will discuss one more method. With the help of that method also, you can find RL value, right? So can you guess what is the method that I am going to discuss now in order to find RL? Now I am going to discuss second method regarding RTH calculation. RL is nothing but RTH. So regarding RTH, I am going to discuss second method. Any guess? Yes, we will use test source method. Okay, so whenever we are using test source method, okay, so generally whenever you want to find the equivalent resistance across the open circuit terminals, okay, so whenever in the circuit along with resistors, if you are having only dependent sources, okay, then obviously that question you can solve with the help of only test source method. Okay, but even the test source method we can apply for the circuits whenever you are having along with dependent source, even if you are having independent source. Okay, so but only one condition here, whenever you are using test source method, what we have to do, whatever I have mentioned. Okay, say for example, in this particular circuit, if you are having only independent sources along with resistors, that time, in order to find the RTH, what is the first step you will apply? The same first step here also you have to apply. After that only you can use the test source method. That means here 10 volt, you are having voltage source, we have to make it as short circuit, right? Okay, if you are having suppose current source, then that time we will make it as open. Correct? Yes, very good, Manoj. So here first step is we have to make this independent voltage source as short. Okay, but generally sometimes students used to consider this voltage source, or similarly whatever the current source is there, independent source, they will consider, after that they will use the test source method, but that is wrong. Okay, but you have to make sure that whenever you are applying test source method, whatever the circuit you are having, in that circuit if any independent source is there, first of all you have to replace those independent sources with their internal resistance, right? After that only you can apply the test source method. Now here you are having 10 volt source, so that one we have to make it as short circuit. Since it is voltage source, we have to make it as short circuit. This is the first step. Okay, right? Now after this, if you observe across these two terminals, you are having resistors, but in addition to the resistors, you are having simply dependent source, right? So that is the reason now we will connect one test source across these two terminals. Where we are supposed to calculate RTH, across those two terminals, we can connect either voltage source or we can connect either current source. Okay, so it is very simple. If you are following, whether you are connecting voltage source or current source, ultimately RTH value will remain same. But if you want to solve the question easily in less time in the GATE exam, it is very simple. Say for example, if you are connecting one current source here, say for example 1 ampere current source you are connecting here in this particular branch. So with the help of that, so all of you please respond. Are you able to get the current flowing in this particular branch, or are you able to get the voltage across this particular branch? With the help of, suppose if I am connecting one current source here, if I am connecting one ampere current source, say for example, because of this 1 ampere current source, can we find the current flowing in this particular branch? Or can we find the voltage across this particular 6 ohm resistor directly? Is it possible? Whether any of those two values, whether we are able to get with the help of this 1 ampere current source. No, right? Suppose. Now I have connected 1 volt voltage source. Suppose I have connected voltage source which is having the value 1 volt. Now in this case, can you tell the voltage across this 6 ohm resistor, or at least can you tell the current flowing through this particular 6 ohm? Anyone at least. With the help of this 1 volt source, whether you are able to get the voltage across this particular 6 ohm, okay, or whether you are able to get current flowing in this particular 6 ohm. In the previous case, with the help of 1 ampere current source, we cannot find the current flowing in this branch, or we are unable to get the voltage across this particular branch. But in this case, yes, in this case both are possible. See, once if you know across, whenever two elements are connected in parallel voltage same. Suppose instead of 6 ohm resistor present here, suppose example you are having some resistor here, suppose you are having one more resistor here. Okay, so that time if you are connecting 1 ampere current source, in that case, in this particular branch you are able to know how much current is flowing. Once if you know current, once if you know the resistor, you can calculate the voltage. So in that way you can apply common sense. With the help of voltage source, am I able to solve the question easy? Or with the help of current source, whether we can solve the question easy? Very simple. Whenever, if any resistor is there like in series, that time better connect current source, because in series current will be same. Whenever you are having one resistor in parallel, that time in parallel voltage will be same. That means you can connect voltage source. That's all. That is the hint. Okay. Now here, because of this 1 volt source, you are getting voltage across 6 ohm resistor is same 1 volt. Okay. Now by using Ohm's law, you can find the current flowing in this particular branch 1 divided by 6. Okay, right. Similarly, the moment you got 1 by 6, here 2i value will become 2i value will become 2 into 1 by 6. That is nothing but 1 by 3. 2 into 1 by 6, that is nothing but 1 by 3. 1 by 3. Okay. So, here, say for example, since you have connected one voltage source, independent source, okay, you can assume that whenever you are having source, obviously current will leave from positive terminal. So the current leaving in this particular branch, for the timing I am labeling as I1. Okay. So here I connected one voltage source, that means voltage source value I know. And somehow or other, if you are finding current value, after that I will use Ohm's law. So with the help of that, we can calculate the RTH. That's all. So now you can apply nodal equation at this particular node. Nodal equation you can apply at this particular node. So in this branch, you can assume that current is leaving. Okay. So from whenever you don't know whether current is entering or leaving, you can assume that current is leaving. Okay. So here node voltage with respect to ground, you are having 1 volt minus. Here you are having 1 by 3 volt. Here you are having 1 by 3 volt. Divide by 4 ohm. Okay. You are having 4 ohm resistor. Here, right hand side you are having 1 volt, left hand side you are having 1 by 3. So 1 minus 1 by 3 divided by 4. And in this particular branch, we already calculated the current, that is 1 by 6, since it is leaving positive. Whereas I1 current is entering. Entering current is negative. Minus I1 is equal to 0. From here, bring I1 to the right hand side, it will become positive. So 3 minus 1, that is 2 by 3. Divide by 4 plus 1 by 6. So here 2 times, 3 and 2 both are in the denominator, so 3 2s are 6. So that means you are getting 1 by 6 plus 1 by 6. From here we can write 2 into 1 by 6, which is nothing but 1 by 3. So here I1 units are ampere. Units are ampere. Now here you just apply Ohm's law, that's all. Okay. You are having 1 volt source, voltage equal to current. Here I1 into resistor. Resistor is nothing but RTH. RTH. Okay. So 1 volt already value, you know, voltage value is 1. Okay. Here current value got 1 by 3. Current value got 1 by 3. Here 1 equal to 1 by 3 into RTH. So from here RTH equal to 3 ohms. So in this way, whenever in the question they are asking only RL value or only RTH, you can use the test source method. But only the precaution, whenever you are applying test source method, if you are having in the network only dependent sources along with the resistors, then directly you can connect one test source. But along with the dependent sources, if you are having any independent sources, you have to replace the independent sources with their corresponding internal resistance. Then definitely whatever the value you are going to get, that value will be correct. And in fact, with the help of test source method, you can get the answer quickly. That is the reason I always will recommend whenever the question is regarding purely related to the RTH calculation or RL calculation. Okay, but whenever the question, if they are asking PL max, okay, obviously for that, in that formula you are having both VTH and RTH. So with the help of first method, obviously you are calculating VTH. After that, based on your convenience, either you can find the short circuit current or with the help of test source method, whichever at that point of time, with the help of whichever method you feel comfortable, you can solve the question less time, obviously you can go ahead. But I am giving the hint, whenever the question is just to calculate RTH or RL value, whenever you are having combination of dependent sources and independent sources or only dependent sources along with the resistors, that time always recommend test source method. With the help of this method, you can get the answer quickly. Okay, so I hope it is clear for everyone. So regarding RTH value. Okay, so we'll discuss some more questions after some time. So before that, I am going to announce, I know that most of you are preparing for 2024, but some of you are, maybe your friends or juniors might be targeting for GATE 2025 or 2026. So for that, I am going to announce here at our IMS GATE Academy, we are having live online program for GATE 25 and 26. Okay. So here, if you are joining our live online program for GATE 25 or 26, what are the benefits that you are going to get? Here you are able to get live the access of 800 plus hours of live online classes. Here all our faculties will discuss each and every concept, whatever the subjects that you are having according to your branch with respect to GATE exam syllabus point of view, right? All those subjects are you already studied in the BTech, but still, even though you might be having some knowledge, but still we will discuss each and every concept from the basic level, so that once if your basics are strong, then no matter the level of the question in the GATE exam, you will be in a position to solve, and in fact you can get the correct answer, right? So in the live classes, we will discuss each and every concept from the basic level to the application level, and we will discuss all the variety of questions. Okay, and whenever that particular subject is common for 3 branches or 2 branches or 4 branches, okay, we will discuss the GATE questions from all those branches, okay, so that all the students will get more awareness in order to get deeper understanding about the subject and method of solving any problem regarding that particular subject, right? And in addition to that, we are going to provide for all the subjects, we are going to provide theory books, exercise books, right? And in the exercise books, you will be having 3 levels of questions like easy, medium, and difficult, like level 1, level 2, level 3. So while you are practicing these exercise book questions, you are getting good command over the concepts and regarding the method of solving any particular question regarding those subjects. Okay, and not only that, in addition to that, we are going to provide GATE question bank. In this GATE question bank, you are having 30 plus years previous year GATE questions, right? And in this GATE question bank, we are providing, based on the possibility for that particular question, we are providing more than one possible solution. So you are getting lot of concept understanding and method of solving regarding the GATE questions. Okay, so you are getting good command over your according to your respective subjects as per your branch. Okay, so from the classes you are getting good command. In addition to that, you are getting good practice with the help of theory book, exercise book, and GATE question bank. And in addition to that, we are going to provide online tests. Together we are having more than 130 tests. Okay, for every chapter we are going to provide chapter test. Similarly, for every subject we are going to provide basic level test, advanced test, and then like multi-subject test, right? So once if you are attempting the tests in this sequence, like chapter level, then basic test, advanced test, and then multi-level, so your journey regarding the subject, whatever the confidence level, in order to increase further, we are providing in that sequence. And once if you are getting good command after attempting multi-subject test, we are going to provide mock test series. Okay, so in these mock tests, you will get, just like real GATE exam, we are going to provide similar pattern of questions, and in fact some questions we are going to put, the level of those questions is ahead or far beyond GATE level, so that whenever the difficult question come, how you are tackling or how you are attempting during that 3 hours, right? Once if you are getting that environment expo, then definitely you will feel your real GATE exam as easy, right? So here we are going to provide total 130 plus various tests. Okay, and in addition to that, we are going to provide 12 my plan sessions. In those sessions, each and every student whoever enrolled for our program, they can get the proper study plan and guidance regarding for their GATE exam. Okay, so these are half an hour sessions. Each and every student, they can book on monthly 1 my plan session with the corresponding mentor, right? So whoever interested, they can book the free counseling session. Okay, regarding this particular link already provided in the description, and otherwise you can directly contact to these numbers. Okay, so all of you share this valuable information with your friends and juniors. And one more announcement I am doing regarding our IMS GATE Academy Telegram channel. So this is free for everyone, right? So all of you can join our Telegram channel. So if you are joining in this particular Telegram channel, so what are the benefits that you are going to get? Say for example, currently GATE score booster session regarding network theory subject is going on. Similarly, according to your branch, okay, whatever the upcoming live sessions are there, our faculties will share whenever the upcoming live session is there regarding that particular YouTube link. We will share in this particular Telegram app, and whatever we are explaining, Okay, whatever we are writing on this particular digital board, after the class over, after the live session over, we are going to share the PDF, lecture PDF in the same Telegram group. And in addition to that, you are going to get, whenever we are conducting any seminar or webinar, you are going to get the updates. And similarly, whenever any job notification regarding PSU or any other government job, so regarding those notifications also, we are going to provide here in this particular Telegram group, so that all of you are getting day-to-day update, right? And in addition to that, we are going to provide daily basis, we are going to provide one quiz question, so all of you can participate in that quiz. Okay, so one Monday we will post one related to one particular subject question, right? So all of you can attempt that quiz question, and the very next day our faculties will provide the solution for that quiz question. So later you can go through that explanation and you can cross check. Suppose if your answer is correct, it is excellent. Suppose due to any reason, if you have chosen wrong answer, you can go through the explanation, so you can easily rectify where you have done the mistake. Okay, in this way, on daily basis, you are getting one quiz question, so you are getting good opportunity to learn something on daily basis, right? So these are the advantages are there if you are joining our Telegram group. So all of you kindly join. Okay, if you not yet joined now, okay, please join whenever you are having free time. So regarding this particular link is also provided in the description. Okay. Right. Now let us discuss the remaining questions. Okay. So just observe this particular question. Can you identify the chapter name? This question belongs to which chapter? Just observe the circuit diagram. Can you identify the chapter name? Yes, in this circuit diagram, if you observe, you are having voltage source, resistors, and capacitor is there, and here you are having switch, right? And the arrow mark is there. Okay, at t equal 0, we are opening the switch, right? Whenever switch symbol is there in the electric circuit or network problem, that means the question belongs to transients, right? Transients. So all of you give it a try. So in this particular question, we are asking the voltage across capacitor. Voltage across the capacitor. In this entire circuit diagram, you are having only one capacitor. Its value is 30 millifarad. So across this capacitor, you have to find out the voltage, and regarding the time instant we have mentioned at 0.6 seconds, you have to calculate. That is the question. So regarding that, you are having 4 choices. Obviously, one choice will be correct. This is the MCQ question. Generally, some students used to feel that the transients chapter of network theory subject is very tough. Okay, but I am in this particular session, I am going to discuss 2 questions regarding transients chapter. Okay, just if you follow my explanation and method of solving, you will feel dead easy regarding transients, and in fact, you will get good command over the transients, and in fact, in the GATE exam, regarding network theory subject, you will be having more interest and eager in order to attempt transients question only at the first. Okay, that much easy and simple I will make in some time. Okay, but meanwhile, all of you give a try, right? Whoever having good knowledge about transients, please give a try, and whoever feel the transients chapter is tough, but still you can give a try. Okay, and just have some patience. I am going to discuss 2 questions regarding transients. With the help of these 2 questions, you are getting good command over the transients topic. Yeah, time up. Yeah. So whenever you're having transient question, okay. So in general, in the circuit, there are two ways to identify whether the given question belongs to transient chapter or not. One variety, okay, whenever in the circuit, if you're having switch symbol, okay, that is giving indication, and sometime regarding the voltage sources or current sources, they will represent like step voltage, U of t or delta of t, etc. So whenever you're having any step signal, etc., that means test signals if you're having, right? So that also giving the indication that that question belongs to transient. Okay, right. Now just if you observe here in this particular switch symbol, if you observe switch symbol, at t equal 0 instant, we are opening the switch. At t equal 0 instant, we are opening the switch. So that means here for the timing, I'm drawing the time axis. Okay, this x-axis or time axis. Okay, for the timing, I'm considering time axis. Say for example, you have operated already the circuit at t equal to minus infinity. Okay, now at t equal to 0 instant, we are making some switching action. Whether we can open the switch or we can close the switch. Okay, but that action we are doing at t equal 0 instant. Okay, right. Now just observe here. So just by observing the circuit at t equal to 0, we are opening the switch. That means till just before that particular instant. That means slightly just before that instant. Say for example, that one I am considering like 0 minus. So up to this particular instant, whether the switch is in the closed position or not. Yes, obviously it is in the closed position. So now if you observe, since you already operate the circuit at t equal to minus infinity, now with respect to that sense, at t equal to 0 minus instant, already the circuit has been reached to the steady state or not? All of you please respond. Once if these basics are clear for everyone, then no matter the level of the question regarding transients, all of you can attempt the question correctly. That much guarantee I am going to give. But basics you should be strong. See, t equal to 0 instant, at that particular instant we are opening the switch. That means slightly before the switching action, already the switch was kept closed, right? So that means at t equal 0 minus instant, already the circuit has been reached to the steady state, right? So this is the first and foremost observation point. Now first of all, whatever may be the parameter or values they are going to ask in this particular transient, first of all, you have to consider, this is the first and foremost observation. You have to consider the circuit diagram at t equal to 0 minus. Okay. So here at t equal to 0 minus, circuit is in steady state. Okay, circuit is in steady state. Right. Now first of all, just by observing the circuit diagram, up to t equal 0 minus, switch is in closed position only. Right. So that means regarding the switch, I am keeping the closed position only. Okay. Here voltage source, resistors, I have kept as it is. Now, in this circuit, you are having capacitor. Now, all of you please respond. In steady state, capacitor acts as open circuit or short circuit? In steady state, capacitor acts as open circuit or short circuit? Capacitor acts as open circuit. If you are having inductor, then it will act as short circuit. Okay, right? So I hope all of you know. In steady state, capacitor acts as open circuit. So that means here in this particular circuit, you are having capacitor. Since I am considering the circuit at t equal 0 minus, capacitor become open. Right? Now, across the open circuit terminals, I am calculating the voltage at this particular instant. So that is the reason I am labeling as VC of 0 minus. Okay, right. Now, Here 60 ohm, 30 ohm. How these two are connected? Parallel. So regarding this equivalent resistance, how much you are going to get? 60 into 30 divided by 60 plus 30, I am directly writing 90. So 30 3 times, 3 20 times. So that means you are getting 20 ohms. Regarding this equivalent resistance, you are getting 20 ohm. 20 ohm. So that means the voltage across this open circuit terminals is same as the voltage across this resultant combination. If you want individually also you can consider. Across this 30 ohm, across 60 ohm, all are same only. But when there is a possibility to simplify, better do it so that you can get the answer quickly. That is the reason I have done simplification. So across this 20 ohm resistor, what is the voltage you are getting? That voltage is nothing but Vc of 0 minus. Okay. Now here you are having 10 ohm resistor. Okay. Now just observe this 20 ohm resistor and 20 ohm resistor. These two are connected in parallel. Okay. Piyush, any doubt is there? Piyush, we are discussing the questions for gate. Do you have any doubt? Here for understanding purpose, I am discussing the basic concept. Okay, right. So here 20 ohm, 20 ohm, both are parallel, right? So that means you are going to get 10 ohm, 10 ohm, right? Now just tell me, this 10 ohm resistor, this 10 ohm resistor, how these two are connected? How these two are connected? These two are connected in series. So 10 ohm plus 10 ohm, that means you are going to get 20 ohm. You are going to get 20 ohm. Yeah, great, Pish, great. Okay, now tell me, what is the voltage at this particular node with respect to ground? Any guess? Just by observing the circuit diagram. Just by observing the circuit diagram, can you tell what is this node voltage with respect to ground? See, here these two are connected in parallel. In parallel, voltage will be same. So since already you know the voltage source value 50 volt, obviously the voltage across 20 ohm also same 50 volt, and the voltage across this particular node with respect to ground same voltage 50 volt, 50 volt. Now if you observe this overall circuit, you are having here 50 volt, here 20 ohm, here 20 ohm. Okay, so just for understanding, I am just drawing the simplified circuit. 50 volt, then 10 ohm plus 10 ohm, that means 20 ohm you got. Here of course you are having 20 ohm, just one second. Here 20 ohm resistor is there. So for the time being, here I am considering the voltage source value, that is 50 volt. Next, here I got 20 ohm. Okay, if you want, you can connect these two, but the other resistor value for the time being it is not required. Here 50 volts, then 20 ohm, then 20 ohm, 20 ohm. Now can you tell the voltage across this 20 ohm resistor? Yeah, thank you, Piyush, for your compliment. But your answer is wrong. You can cross-check once. See here, 20 ohm, 20 ohm. See, the moment you know the voltage across this particular branch is 50 volt. Now, how these two are connected? How these two are connected? Yeah, Piyush, this is the network theory subject. This is for GATE exam point of view. For EC, electrical and instrumentation. Okay, right. So here these two are connected in series, right? So in series, current will be same. In series, current will be same and voltage will get divided. Here you are having 50 volt, here 20 ohm resistor, here 20 ohm resistor, right? So since both are having equal value, that means whatever supply voltage you are having, that will get half of that one here, other half here. So that means directly you can write 25 volts. 25 volts. Okay, I hope all of you are getting. So as of now, we got the initial voltage, that is 25 volt. Okay. So here Vc of 0 minus is equal to Vc of 0 plus, which is equal to Vc of 0, or otherwise if you want you can write simply V0. All are same. Initial voltage. So according to this question we got 25 volts. According to this question we got initial voltage 25 volt. Okay. So this is the first step. Whenever we are solving any question regarding transients, first of all you have to find the initial voltage. So regarding that particular initial voltage, in general students will do silly mistake by considering the circuit at t equal 0 plus. But whenever you are considering directly the circuit at t equal 0 plus, sometimes your answer may be correct, but most of the times your answer will be wrong. Because at the transient time, just before the switching action and just immediately after the switching action, the voltage across the capacitor value won't change. That is the reason. Okay, right. So here, in order to find the initial voltage, we have to consider circuit diagram at t equals 0 minus. Okay. Now we have to consider the circuit diagram for t greater than or equal to 0. Now we have to consider the circuit diagram for t greater than or equal to 0. Okay, right. So here, if you observe, after the switching action, that means here at t equal 0, we are opening the switch. The moment if you are opening the switch, what will happen? Here you are having the rest of the circuit like this. Rest of the circuit here you are having like this. Okay. Now I am going to draw that circuit after the switching action. Now I am considering the circuit for t greater than or equal to 0. Okay. So here already I have kept switch open. Okay. So here 10 ohm resistor, 60, 30. Now here the most interesting thing is here only. Yeah, Piyush, you can attend general aptitude class. Okay. So currently we are discussing the technical subject. Fine. So here you are having capacitor which value is 30 millifarad, right? Capacitor value is 30 millifarad, and just now we got initial voltage as 25 volt. So this initial voltage we have to kept in series. Initial voltage we have to consider, and we have to keep this one in series with the capacitor. So here the capacitor value is 30 millifarad. 30 millifarad. Okay, right. So now just observe the circuit diagram. After the switching action, since the switch was kept open, so that means whatever this independent source is there, this is there nowhere, there is no connection with this particular part of the circuit, right? Okay. Now just if you observe, here 10 ohm resistor is like open, so we can neglect this particular resistor. Okay. Now these two resistors are connected in parallel. Regarding that, we already got the equivalent value. How much? 20 ohm. We got 20 ohm. Now here you are having 25 volt source, that is the initial voltage, and you are having capacitor value 30 millifarad, and here you are having 20 ohm resistor. Okay, right. So that means now if you observe this part of the circuit, if you observe, now this part of the circuit belongs to after the switching action. After the switching action, there is no independent source connected to this particular circuit. Okay, whatever this voltage you are having, that is initial voltage that was there in the capacitor that we have considered. But there is no independent source was connected here. So that means this particular part of the circuit after the switching action, it is a source-free RC circuit. It is the source-free RC circuit. Okay, so whenever you are having source-free, because there is no independent source connected here, obviously at the last, that means at t equal to infinite, obviously the voltage across capacitor will become 0. Whatever this initial voltage you are having, that particular initial voltage, slowly at t equal to infinity, it will become 0, right? So here for t greater than or equal to 0, whenever if you want to find the voltage across capacitor, the formula is Vc of t equal to V naught, that is the initial voltage across capacitor, into e power minus t by tau. Okay, so here in this case, tau value we have to find out, where tau is nothing but R equivalent into C equivalent. Where tau equal to R equivalent into C equivalent. Okay, so here if you observe this part of the circuit, you are having only one capacitor, 30 millifarad, right? 30 millifarad. So that means obviously here C equivalent is 30 millifarad. Milli is nothing but 10 power minus 3. Next, here in this particular circuit, just make voltage source as short. Then 30 millifarad here you are having, just make it as open. Then across this open circuit terminals, you are having only one resistor, that is 20 ohm, right? So that itself is the R equivalent. So R equivalent is 20. So 20 into 30, that is nothing but 2 3s are 6, 600, right? 10 power minus 3, we can write as 1 by 1000. So that means 2 zeros will get cancelled. 6 by 10, we can write as 0.6. Units are seconds because it is a time constant, R into C. Okay. Now in the question they are asking to calculate the voltage across capacitor at what instant? Calculate the voltage across capacitor at t equal to 0.6 seconds. T equal to 0.6 seconds. So now consider at t equal to 0.6 seconds, the voltage across capacitor. Here V naught, initial voltage we got 25 volts. 25 into e power minus t by, t value they have considered 0.6 seconds. Okay, so 0.6 divided by tau value, just now we got same 0.6 only. So 0.6 will get cancelled. So that means you are getting 25 into e power minus 1. So all of you do the calculation. You can use your calci or you can use mobile. Yeah, Piyush, currently we are discussing all the live sessions in the English only, okay? So if you are facing any problem, later you can watch this lecture. Yeah, all of you do the simplification, how much you are going to get? Yes, I hope all of you are getting 9.2 volts. So the answer for this question is 9.2. So just observe the given choices. 9.2 we are having in option D. Option D, right? So option D is the correct answer. Okay, so I hope all of you got the clarity. So whenever you are getting any question regarding transients, first of all, we have to find the initial condition by considering the circuit at t equal 0 minus, and after that, we have to consider the circuit diagram for t greater than or equal 0. For that particular circuit, you have to find the time constant. Okay, right. Okay, next question. This is the MSQ. So all of you give it a try. In this particular question, you are having the capacitor here. Regarding this capacitor, you have to find out the voltage. Regarding the voltage, you are having two choices. And regarding the current here you are having, right? In this particular branch, how much current is flowing? Regarding the voltage and current, in this question, I have mentioned that at t equal to 1 second. At t equal to 1 second, you have to calculate the voltage across capacitor. And at t equal to 1 second, you have to find the current flow in this particular branch. So after that, you can choose among option A, option B, which one is correct. Similarly, among option C and D, which one is correct. Okay.
But lot of messages. Letting lot of misinformation. Click on that. This chart. How to block it?
That I have to do that, sir.
Yeah. Now let us see this question. This is a very interesting question related to transients, right? So in this particular circuit diagram, you are having the capacitor here. Across this capacitor, you have to find the voltage. Similarly, in this particular branch, you have to find the current. Regarding this voltage and current, at t equal to 1 second, you have to calculate. And since two choices are regarding voltage, since two choices regarding current, so among option A, option B, at max one option can be correct. Similarly, among option C and D, at max one option can be correct. Okay, right. Now let us see whatever the method I have discussed in the earlier question, same approach you can follow. Same approach you can follow. Here, first of all, whenever just observe the circuit diagram, just consider the circuit diagram at t equal to 0 minus. That means just before the switching action, you have to consider the circuit. Okay. At t equal to 0 minus, at t equal to 0 minus, circuit is in steady state. At t equal to 0 minus, circuit is in steady state. Okay. In steady state, capacitor acts as open circuit. In steady state, capacitor acts as open circuit. Okay, right. Now we have to consider the circuit diagram at t equal to 0 minus. Now here in this question, in this circuit diagram, if you observe, you are having the switch that indicates this question belongs to transient problem, and in addition to that, here if you observe, you are having the voltage source representation in terms of u of t. U of t is what? Step function. So this value is going to present from t equal to 0 instant onwards. Okay. So whoever not having that much knowledge regarding 30 u of t, okay, for that I am representing here. So regarding 30 u of t, 30 u of t, see regarding the step signal, u of t value starts from 0 and it is going up to infinite, right? So its value will be 1. But here you are having 30 times. So because of that, we have to multiply with 30. So this is 30 times u of t. 30 times u of t. Suppose if it is only u of t, so that means u of t value is 1, like that. So now you can observe from this diagram also, you will come to know that the given circuit is belongs to transients, right? So just observe from minus infinity to 0, you are having this supply voltage value is 0. From 0 to infinity, you are having 30 volts. So that means up to t equal to 0 minus, we haven't connected this source. Okay. Whereas from 0 instant onwards, we are connecting this particular voltage source like that. Okay. So in that way also you will come to know that question belongs to, the given question belongs to transients. Okay. So for the time being, we are considering up to 0 minus. Okay. At t equal to 0 minus, we are considering. So then u of minus t value, okay, u of t value at t equal to 0 minus is 0, right? So because of that, since this value is 0 and if it is current source, we could have made open. But since it is voltage source, whenever voltage source value is 0, that means we have to short circuit the terminals, right? Short circuit the terminals. So this is a very interesting thing. Okay, up to t equal to 0 minus, here u of t value is 0 because here it is the voltage source. Since voltage source value is 0, we have to make the short circuit. We have to make the short circuit. Okay, after that 10 ohm resistor, 20 ohm resistor. Okay, after that this is the closed path. Now, here you are having capacitor. Capacitor will act as open circuit. Here we have to calculate the voltage across capacitor at t equal to 0 minus instant. Okay, now what about this switch connection at t equal to 0 minus? Just observe here, at t equal to 0, we are opening the switch. That means still before that, the switch is in the closed position. Closed position. The switch is in the closed position. Okay, now just observe this circuit diagram. We have to find the voltage across these two terminals. Okay, now if you directly observe, all these points are same. Similarly, all these points are same. So that means Vc of 0 minus is nothing but directly you can write Vc of 0 minus equal to 10 volt. Vc of 0 minus is equal to Vc of 0 plus is equal to Vc of 0, initial voltage, all are same, equal to 10 volts. 10 volts. In this way, we have to find the initial voltage by considering circuit at t equal to 0 minus. Okay, right. Now in this circuit, just observe, after the switching action, that means for t greater than or equal to 0, okay, that time this switch has been opened, and this voltage source we are connecting, Okay, for this RC circuit, we are connecting this voltage source now. Now, because some independent source we are connecting for t greater than or equal to 0, because of that, in the capacitor at t equal to infinite also you will get some voltage. You will get some voltage. That one we have to calculate. Whereas in the previous circuit, after the switching action, there is no independent source connected. That is the reason we haven't calculated VC of infinity. Even if you want, you can calculate, you will get 0. Okay, whenever there is no independent source connected. But whenever some independent source connected after the switching action, definitely you are going to get some voltage value at t equal to infinity in the capacitor. Okay, right. Now let us calculate that voltage. Now we are considering the circuit at t equal to infinite. At t equal to infinite. Okay, so at t equal to infinite, if you observe here, you are having, regarding this particular 30 u of t, you are having 30. Here units are volts. That means this voltage source we are connecting, and its value is 30 volts. 30 volts. Okay, right. Yeah, thank you, Vikem. Here 10 ohm resistor, 20 ohm resistor as it is. Now at t equal to infinite, once again capacitor will become open circuit, because t equal to infinite means what? Steady state once again. So here we are calculating the voltage across capacitor, but at t equal to infinite, that is VC of infinite. But what about the switching? What about the switch position? At t equal to 0 instant itself we are opening the switch. Obviously at t equal to infinite, the switch was in open position only, right? So there is no connection between this voltage source and capacitor, right? There is no connection between this capacitor and this voltage source. It is forever after t equal to 0 instant onwards, this was open only. So that means this voltage source, if you want, you can remove, because it is like open, right? Okay, we can ignore. Now we have to find voltage across this particular capacitor at t equal to infinite. Now if you observe, since these two terminals are open, okay, and these two terminals are open, obviously here there is no current flowing. In this branch there is no current flowing, right? So if there is no current flowing, obviously these three elements are connected in series, right? In series current will be same, but voltage will get divided. Okay, now you can use voltage division rule. That concept you might have studied in the first chapter, right? Now we are going to apply that voltage division rule now, in order to find voltage across these two terminals, because across these two terminals voltage is same as voltage across this particular 20 ohm resistor. Yes or no? Both are same. Okay, so now we can calculate VC of infinity, which is nothing but the supply voltage is 30 into this branch resistance. Wherever you are supposed to find the voltage, that resistance will come in the numerator, and denominator is sum of resistances. Okay, 20 plus 10. So 20 plus 10 is 30. So 30 into 20 by 30. Here 30 will get cancelled, so you are getting 20 volts. So now you can observe here, because after the switching action, because some independent source we have connected forever, right? So when you are analyzing the circuit at t equal to infinity, because the moment at t equal to 0 plus instant onwards, we have connected the source, right, to this particular capacitor. So with respect to 0 plus instant, at t equal to infinite, already we have reached the steady state. So in the steady state, capacitor always acts as open circuit because of this particular independent source. Now if you observe, you are getting 20 volts. Initially if you observe, because of this particular source, you are getting 10 volts. Now after the switching action, because of the other voltage source 30 volt, here with respect to this resistor divided network, you are able to get 20 volts. Okay, right. So this is the most interesting thing. So in this way, you have to find out the initial voltage, and wherever if you are having some independent source connected after the switching action, that time definitely you are going to get VC of infinity. Okay, in most of the cases you will get non-zero. Okay, but in some cases because of the other elements, suppose here we are considering only R and C, but in some questions you will be having multiple capacitors, multiple inductors, etc. So in some cases, okay, across some capacitor you may get voltage 0. Okay, because across at the other capacitor you are getting some other voltage. Okay, like that. Okay, but for the time being I have considered simple RC circuit, right? So you are getting VC of infinity as 20. Now we have to consider the circuit diagram once again for t greater than or equal to 0. Now let us calculate time constant, just like the previous question, right? So here, just by observing the previous circuit, now I am considering this 30 volt source. We are considering the circuit diagram for t greater than or equal to 0. We have connected this 30 volt source from t equal to 0 instant onwards, right? Okay. Now here you will be having capacitor. So this is the most interesting thing. Okay, whenever you are drawing the circuit diagram for t greater than or equal to 0, whenever you are having capacitor, obviously you will be having initial voltage. Unless otherwise you are having initial voltage 0, whatever the initial voltage you are having, that you have to represent in series with the capacitor, right? So initial voltage we got 10 volts, and here the capacitor value is 1 by 4 farad. Initial voltage we are having 10 volts, and here we are considering the capacitor value, that is 1 by 4 farad. Okay, from t equal 0 instant onwards, we kept the switch open position, so that means this 10 volt source we can remove from the circuit. Okay, it is not playing any role. Now if you observe this part of the circuit, okay, you are having here 10 volt because of the initial voltage across the capacitor. Okay, you are having independent source here and then resistors, capacitor. So now if you observe this part of the circuit, you are having the circuit with the sources. After the switching action, sources are present, right? So this particular circuit is the case where you are having with the sources. The previous circuit which we have considered is without any independent source after the switching action. Anu, actually time constant I not yet calculated, I will calculate. Okay, for the timing I have drawn the circuit for t greater than or equal to 0. Okay, right. So now we have to find the time constant. Okay, whenever you are supposed to find the time constant, okay. So now if you observe this part of the circuit, you are having with source, and it is in this particular circuit you are having the elements related R and C, resistor and capacitors, right? So in this overall circuit you are having only one capacitor. Obviously, when you are calculating the time constant, okay, so time constant formula is R equivalent into C equivalent. Since in this entire circuit you are having only one capacitor, obviously C equivalent value will be same. Okay, C equivalent value will be same. C equivalent equal to, in this case you are having 1 by 4 farad. Now whenever you are having multiple resistors, okay, now we have to find the R equivalent in such a way that first of all we have to remove the capacitor from the circuit. The moment if you remove the capacitor, then terminals become open. After that, across the open circuit terminals, you have to find the R equivalent. That time, since in this circuit you are having voltage sources, you can make voltage sources are short. Okay, when you are making voltage sources are short, then after removing capacitor, then across these two terminals, how 10 ohm resistor and 20 ohm resistor are connected. So for the time being, I am drawing the simplified circuit like this, or equivalent representation. So all of you just identify and tell me. Here in this case, 10 ohm, 20 ohm. How these two are connected? Yeah, Anup, you can answer now. Even other students also can answer. How 10 ohm and 20 ohm are connected? Yes, just observe here. This point, all are same, right? So from this point to this point, you're having one resistor like this, and in this branch you're having one more resistor, right? So these two are connected in parallel. These two are connected in parallel, right? So R equivalent equal to 10 parallel to 20. So that means 10 into 20 divided by 30. So here 1 0 will get cancelled. That means you're getting 20 by 3 units are ohm. Units are ohm, right? So now that R equivalent and C equivalent you can substitute here. R equivalent just now we got 20 by 3 and C equivalent we got 1 by 4. So that means here 4 5 times. So that means you're getting 5 by 3 units are seconds. Is it clear, Anup, now? Okay, I hope it is clear. Still, if you're having any doubt regarding the time constant, how to calculate, you can ask. Okay, I will repeat once. Okay, so we calculated the time constant. We calculated the initial voltage. We calculated the final voltage, right? Now, whenever you're having like this, okay, in order to find the voltage across the capacitor for t greater than or equal to 0, in order to find the voltage across capacitor for t greater than or equal to 0, voltage across capacitor for t greater than or equal to 0, the equation will be like this. Vc of t is equal to V final minus V initial, V final minus V initial into e power minus t by tau. E power minus t by tau. Okay, so we got Vc of infinity as how much? Vc of infinity we got 20 and initial voltage 10. Vc of infinity 20, initial voltage 10 into e power minus t by tau. Tau value we got 5 by 3. Okay, tau value we got 5 by 3. So from here, I am doing the reciprocal. So that means I am getting 1 by tau. 1 by tau as 3 by 5. Here units will be second inverse or per second you can write. Both are same. So 3 by 5 you are getting. So e power minus 3t by 5. Okay. So from here we will get 20 minus 10 is 10 into e power minus 3t by 5. E power minus 3t by 5. Okay. So this is voltage across capacitor. Voltage across capacitor for t greater than or equal to 0. Okay. Now in this question if you observe, for t greater than or equal to 0, you are having a circuit diagram like this, right? So according to the given question, the current flowing in this particular branch, they have mentioned as I of t. But since for t greater than or equal to 0, there is no connection between these 2 points because which was kept open. Now whatever the current flowing in this branch, the same current will flow like this, right? So in the capacitor, the current is flowing like this. So that one we will represent as IC of t. Since there is no current flowing here, whatever the current flowing in this branch, same current is flowing like this, right? So because of that we can write I of t equal to IC of t. Okay, sorry, here it is not inductor, sorry. Current flows through capacitor. Current flows through capacitor for t greater than or equal to 0. For t greater than or equal to 0, right? So here IC of t we have to calculate. IC of t we have to calculate. So that is nothing but C into dV by dt. C into dV by dt. Okay, so here according to the given question, right, capacitor value is what? 1 by 4 farad. Okay, capacitor value is 1 by 4 farad. Now, we have to perform differentiation of whatever the voltage just now we got. Just you can substitute here. 20 minus 10 into e power minus 3t by 5. 3t by 5. Yes, currently we are discussing the questions regarding transients. Okay, so regarding transients also I have given the hint point. How to find the initial voltage or how to find the time constant, etc. Okay, so you will get the shortcuts or tricks in the upcoming chapter questions. Okay, after some time I will discuss. Now just perform the derivative. 1 by 4 is the constant we kept as it is. Derivative of constant is 0. Then minus 10 is the constant we can keep as it is. Then e power minus 3t by 5. Derivative is what? E power minus 3t by 5. And derivative of this power value, you will get minus 3 by 5. So here minus into minus plus 5 2 times 2 2 times. So that means you are getting 3 by 2 into e power minus 3t by 5. Okay, so here we got the current flowing through the capacitor, right? So as I have already mentioned, the current flowing through the capacitor and current flowing in this branch both are same, right? So from here we can make I of t equal to IC of t equal to I of t equal to this expression 3 by 2 into e power minus 3t by 5. Okay, now in this question we are asking to calculate the voltage and current at t equal to 1 second. So all of you can substitute t value 1 in these two expressions and try to find out regarding the voltage and regarding the current. All of you give it a try at t equal to 1 second. So if you are substituting t equal to 1, then you will get 20 minus 10 into e power minus 3 by 5. Similarly here, I of t equal to 3 by 2 into e power minus 3 by 5. All of you do the simplification by using calculator or mobile. So here you will get, after doing the simplification, you will get 14.5 volts. And regarding this one, you will get 0.82 amperes. I have made the approximation, so accordingly you will get. Okay, so here you are going to get 14.5 and regarding current 0.82. Now just observe the choices. Yeah, 14.5 we are having in option B and 0.8 ampere we are having in option D. So option B, option D both are correct. So the final answer for this question, you are having two choices, both are correct. Option B and option D. Is it clear for everyone? So with the help of previous question, I have discussed after the switching action, there is no independent source connected, whereas in this particular question, after the switching action, we are having some independent source was connected. Okay, whenever there is no independent source connected to the network, after the switching action, obviously across the capacitor at t equal to infinite, if you are calculating any voltage, obviously you are going to get 0. Okay, but whenever some independent source connected after the switching action, definitely because of that particular source, you will get some voltage at that particular capacitor. Okay, but whenever you are having multiple capacitors and inductors, etc., that time in some capacitor you may get voltage as 0. Okay, but in general you will get other than 0. That is the reason I have stressed multiple times. Okay, so whenever you are getting like independent source connected after the switching action, so because of that you will get final voltage. Now this is the standard formula. This is the standard formula in order to find the voltage across capacitor. Similarly, like this formula, okay, in place of V, if you are keeping I, okay, that formula will applicable for current flowing through the inductor, right? So similar formula you are going to get, okay. Say for example, whenever you are having source free circuit, after the switching action, if there is no independent source connected, that means final value is 0. Okay, the moment you are keeping final value as 0, okay, here minus into minus is what? Plus Vc of 0 into e power minus t by tau. So that expression I have already written in the previous question, right? So whatever that source free circuit equation you are having, that is a derived version from this standard equation. Okay, I hope all of you are getting the clarity. Is it clear for everyone? All of you please respond. So up to now we have discussed the questions regarding transients. Okay, now we are going to discuss the questions based on steady state. So all of you give a try. In this particular question, you are having the circuit diagram. In this circuit diagram, you are having resistors, inductors, and capacitors. Right? Resistors, inductors, and capacitors you are having. Okay. In this question, if you observe the beauty of this question, you are having this question is of MSQ. Either one option or more than one option can be correct. Okay. So the voltage across 5 ohm, it is mentioned as V 5 ohm. Regarding that, you are having one choice. And the current flowing in this particular 5 ohm resistor is I. Regarding that, you are having two choices. And in option D, the power across this particular 5 ohm resistor it is mentioned. Right? So regarding this particular resistor, voltage, current, and power. So it is like calculating current flowing in this particular branch, voltage across this particular branch, and power across this particular resistor, like that. Okay. So here you are having four choices. Try to choose the correct one. Okay, either one option can be correct or more than one option can be correct because the question is MSQ. Yeah, this is a very interesting question. Okay. See, when you look at this particular circuit diagram, some of you might be facing the difficulty while solving this or while simplifying this particular given circuit. Okay. See, here just observe, just by looking at the choices only you are getting the clue. Okay, here all the choices related to this particular 5 ohm resistor only. Regarding this particular 5 ohm resistor, how much current is flowing, or how much voltage you are having, or how much power you are going to get. Okay, now if you observe in this entire circuit, you are having one AC voltage source and you are having resistor. After that, you are having here 4 branches, all are connected in parallel. All are connected in parallel, right? So here you are having resistor, inductor, capacitor. Okay, now just observe here in this particular branch. In this particular branch, you are having 2 elements. You are having 2 elements. One is inductor, another one is capacitor, right? So whenever 2 elements which are connected in series, we can add the respective impedances. Okay. After that, we will calculate the overall equivalent impedance. Okay, right. So for the time being, I am considering this part of the circuit. So for the time being, say for example, if you are considering 2 points here, okay. So to the right hand side of these 2 points, whatever the equivalent impedance you are going to get, that one for the time being I am labeling as Z suffix A. Okay, if you want, you can use another labeling, no issue at all. Okay, right. So here I am going to, first of all, I am going to find the equivalent impedance across this particular branch. Okay, in this branch you are having inductor and capacitor. Okay, so I hope all of you know, whenever you are having inductor, right? So the respective impedance is nothing but J omega L, J omega L. Similarly, whenever you are having capacitor, right, the corresponding impedance is nothing but 1 by J omega C, 1 by J omega C. Now, in this question, you are having sine omega t. Here it is in the form of sine omega t, right? So, omega value is nothing but 2. Omega value is nothing but 2. And L value is 0.6 Henry plus 1 by J we can write it as minus J. 1 by J we can write it as minus J. Or you can multiply and divide with J. So numerator you are having J, but denominator J square is nothing but minus 1. So because of that you can write minus J. And once again omega value is 2. And capacitor value here you are having 5 by 12. Capacitor value you are having 5 by 12. Okay. So here 2 6 times 2 into 0.6, that is 1.2. So you are getting J 1.2 plus into minus J. This 6 will go into the numerator, right? So 6 by 5 you are getting. 6 by 5 we can write as 1.2. So here J 1.2, here minus J 1.2. Both are having same value. Magnitude wise same, but polarities were opposite, right? This is plus, this is minus. Okay, so that means you are going to get impedance as 0 ohm. Impedance as 0 ohm, right? So you are having here in this particular branch you are having one inductor and one capacitor. Okay, after calculating the resultant impedance of this particular branch, simply you are getting 0 ohm. 0 ohm. So whenever for any particular branch, if you are getting impedance as 0 ohm, so that means we are simply shorting these 2 points with the help of single wire, that's all, right? So this is the indication. Now, the moment you got like this, can you tell the equivalent impedance with respect to these 2 terminals towards right hand side? Whatever the circuit here you are having, the entire circuit we can replace with what? Any guess? See here, you got, see here you're having R, L, C. Okay, one is resistor, one is inductor, one is capacitor. Okay, if you want, you can find the equivalent impedance. Okay, so regarding these 3, if you want, you can find the equivalent impedance. Okay, you will get some value. Okay, so that means we are replacing this overall network with one single branch which is having some impedance, finite impedance. Now that branch and this branch, both are in parallel. Okay, whenever you're having parallel combination, like Z1, Z2 by Z1 plus Z2. So because this value is 0, so numerator value you are getting 0. 0 by non-zero, you are going to get 0 only, right? So that means this overall network, okay, you can replace with one short circuit because here you are going to get overall impedance as 0 ohm. Okay, so I hope all of you are getting clarity. So for the time being, I am making, say for example here, this overall network. Okay, impedance you are going to get, say for example ZB. And for the time being I am assuming here the equivalent impedance to the right of this entire network I am labeling as Z suffix P. Okay, so Z suffix P equal to ZB parallel to ZA. Okay, so since ZA is 0, you are going to get the overall impedance as 0. Z1 Z2 by Z1 plus Z2. If you want, I will write one more step. ZB into 0 divided by ZB plus 0. Okay, so you are going to get 0 ohm. So that means this overall network we can replace with one short circuit. Okay, that's all. That means the overall circuit you are having only AC source and resistor. Okay, so whenever you are having in any circuit, if you are having only AC source and then resistor, okay, now you can calculate whatever the voltage or current, anything. Okay, you can just by observing you can find whatever the Ohm's law concept or basic laws that we have discussed. Okay, in the first chapter, with the help of that you can easily solve. So here this overall circuit, if you want, I am drawing simplified circuit just for reference. Here you are having 40 root 2 sine 2t, units are volts. After that you are having resistor. For the time being, whatever the resistor given in the circuit, for the time being I am representing vertically like this. See, just observe, whatever this resistor horizontal is there, for the timing I have kept vertical. Because here we are replacing this overall circuit with the help of single wire. Okay, that single wire anyway here you are having. So these two we can short. That means whatever horizontal resistor is there, you can keep vertical. So here you are having 5 ohm and the current flowing through this one is I, and the voltage across this 5 ohm is V5 ohm. So whenever two branches are continued in parallel, voltage will be same. So V5 ohm is nothing but 40 root 2 sine 2t. Units are volts. Now let us analyze or let us check whether any option is matching or not. 40 root 2 sine 2t. 40 root 2 sine 2t. But here you are having 20, right? So option C we can eliminate since it is not matching. Now let us calculate regarding current. I equal to V5 ohm divided by, since you are having only resistor, okay, and its value here in this case you are having 5. So 40 root 2 sine 2t divided by 5. 8 times, right? So that means you are getting 8 root 2 sine 2t, units are amperes. Now tell me whether any option is matching. 8 root 2 you got. 8 root 2. Yes, we are getting 8 root 2 sine 2t. Option B is matching. So the moment option B is matching, we can eliminate option A because both are related to current flowing through 5 ohm resistor only. The moment if option B satisfies, option A we can eliminate. Okay, as of now we have verified 3 options, out of which one option is correct. Now all of you give a try regarding option D, whether it is really correct or not. All of you give a try. See here they are asking power across 5 ohm resistor, right? So I hope all of you know the formula regarding power across resistor. So you can use with the help of voltage equation or with the help of current equation. Okay, your wish. Okay, so for the time being I am considering current equation. So here I am considering IRMS square into R. Similarly, if you want, you can use VRMS square divided by R. Okay, so here IRMS is nothing but Im by root 2. Here already you are having 8 root 2 divided by root 2 whole square into resistor value is 5 ohm. Here root 2 will get cancelled. 8 square is 64 into 5. Okay, so here you will get 5 4s are 20, 5 6 are 30 plus 2, 32. 320 watts. 320 watts you are getting, but in this question, here we have mentioned as 640. Both are not matching, right? So option D we can invent. See the beauty of this question, the title I have mentioned MSQ, and in fact when you look at choice also, two choices you are having related to current, one choice related to voltage, one choice related to power. Okay, so for MSQ question, either one option or more than one option can be correct. Okay, but sometimes students will think that whenever MSQ is there, minimum two choices can be correct. No, not like that. Okay, they can keep the choices in such a way that whatever the choices given, okay, those choices seems to be correct. But that is the reason here in MSQ question there is a surprise is there is a suspense is there, because you don't know really how many correct options are there, right? So you have to, whenever you are having MSQ question, that means the given circuit you are solving like 4 times or 3 times according to the given choices, or even sometimes like 2 choices. Like earlier question, if you observe, 2 choices you are having like related to one parameter or quantity, and 2 choices you are having like one parameter or quantity. So in that way, one MSQ means you are solving the given question either 2 times or 3 times or 4 times based on the given choices, right? So whenever you are solving any MSQ question in the GATE exam, there is no native marking, there is no partial marking. But whenever if you want to solve any MSQ question, just look at the question and decide whether you can solve that question in less time or not. If you are able to solve that question in less time, definitely you can attempt at that time. Otherwise, you can hold that particular question for some time, and later point of time during your exam time, you can attempt those MSQ questions. Because obviously MSQ questions are like time consuming, and since you don't know how many really correct options are there, right? So that's why, that is the reason, whenever you can solve the MSQ question in less time, definitely you can attempt at the initial time only. Okay, right. So all of you please mention how many of you liked this question, how many of you felt this is very interesting. Okay, I kept this question as MSQ, but in this question I have kept only among the given 4 choices, only one option I kept as the correct. How many of you felt this question as interesting? Yeah, I hope most of you, right? So this is the way to learn any subject. Okay, while if you want to revise any concept or method, the best way is while solving the question, you are getting the opportunity to revise. And in fact, while solving the question, if you are getting correct answer, definitely your confidence level will increase. But due to any reason, if you are unable to solve the question, or if you are getting the answer wrongly, or even if you're stucking, no problem. Whatever the methods we are discussing in these live sessions, just go through the explanation part. Definitely you are getting the good command over the subject. Okay, the main motto of the GATE score booster session is, in general, right, whoever students, okay, whatever they have prepared, with that preparation, whatever the marks they are supposed to get, but because of lack of time management or because of silly mistakes, etc., okay, they are losing the marks which they are supposed to get. Okay, whatever the marks they are supposed to get, instead of that they are losing some marks. Okay, so here the purpose of our GATE score booster sessions is for all the students, sincere students who want to increase their marks in the coming GATE exam. So for that purpose we are conducting these sessions. Definitely after attending all the GATE score booster sessions which are coming at our IMS GATE Academy channel, according to your respective branch, try to attend all the live sessions wherever possible. Due to any reason, if you miss any class, no issue at all. Whatever the live session happened, that lecture will be available at our IMS GATE Academy YouTube channel. So just go to the playlist as per your respective branch and watch the recorded lecture in your free time. Definitely after watching all the lectures, okay, whatever the preparation you might have done or whatever the confidence level you might be having before attending these sessions and after attending these sessions, definitely I can say that there will be lot of difference. Okay, and in fact, whatever the learnings you are getting in this series of live lectures, okay, definitely it is giving great value addition with respect to the concepts, knowledge, and method of solving, etc. Okay, so all of you actively participate, and after solving any question, whatever the answer you are getting, please mention the chart. Okay, don't hesitate that what sir will think if my answer is wrong, or what other students may think. Don't worry at all, because ultimately here in these live sessions you are getting the opportunity to learn something new, right? Yeah. So all of you give it a try. This is a very interesting question. In this particular circuit, you're having AC source, you're having inductors, and you're having capacitor, right? So in this particular question, you're supposed to calculate the peak value of the current. Okay, in this overall circuit, in this particular branch, I have kept the current I of t. So regarding that current, you have to find the peak value. You have to find the peak value. All of you give it a try. Yeah, this is a very interesting question. In this particular circuit, you're having the current expression here, right? The current flowing in this particular branch is I of t. And in this overall circuit, if you observe, you're having AC source. It is a voltage source, but it is of AC. Okay, right. Now, see, some of you might be solving this question by using star to delta, delta to star conversion. But actually, for solving this question, that is not at all required. Okay, it seems to be that you might have felt that we may have to apply star to delta, delta to star, but not at all required. The reason is, if you closely observe in this particular circuit, okay, if you closely observe here, just observe here, between these 2 points, here you're having one inductor, and in this branch you're having one capacitor, right? How these two are connected? These two are connected in parallel, right? These two are connected in parallel. Say for example, the equivalent impedance to the right of these 2 points, whatever the network here you're having, okay, so the entire network regarding this particular impedance, okay, I am going to represent, say for example, ZE, okay. So here inductor is there, capacitor is there. I hope all of you know how to find the equivalent impedance, okay. So for the timing, I am representing like this. 1 by Z equivalent is equal to 1 by Z1 plus 1 by Z2. 1 by Z1, where Z1 is nothing but here inductor, right? So regarding inductor, the impedance is J omega L. Similarly, regarding impedance of capacitor is 1 by J omega C. So 1 by J omega C, that one we can write as J omega C. I hope all of you are getting clarity. 1 by Z1 plus 1 by Z2, where Z1 is nothing but J omega L, where Z2 is nothing but 1 by J omega C. So 1 by J omega C is nothing but J omega C. Now, here you are having omega value as 9. 1 by J we can write as minus J, divided by omega is 9 into L value is 1 by 3. L value is 1 by 3 plus J into omega is 9 into capacitor value is 1 by 27. Capacitor value is 1 by 27, right? So here 9 3 times, here 3 times. Okay, so from here you are going to get minus j by 3 plus j by 3. Minus j by 3 plus j by 3. So both are having same, magnitude wise same, but polarities wise opposite, right? One is plus, another one is minus. So resultant value you are going to get 0. So here left hand side you are having 1 by ZA. Left hand side we are having 1 by ZA. This value we got 0. So 1 by ZA, if it is 0, that means ZA will be what? ZA will be infinite. Yes or no? 1 by infinite is nothing but 0. Correct? So you are getting impedance to the right of these 2 points. Okay, this entire network impedance you got infinite. How we can represent infinite ohms in the circuit? Whenever impedance is infinite, how we can represent in the circuit? Any guess? See, in the earlier question we got impedance as 0. 0 means short circuit we have done. Now in this case you got infinite. How we can replace? Yes, very good. It is the open circuit. ZA equal to infinite, that means open circuit. So practical applications, practical cases means very high value. We will keep one resistor which is having very large value, or we will keep one impedance which is having very large value, right? But here theoretically we are getting infinite, right? When we got the calculation, we got infinite. Infinite anyway practical won't exist, but theoretically we can say infinite means it is open circuit. Open circuit. Okay, right. So here this part circuit you kept like open. Now after that if you observe, you are having one inductor. So this inductor there is no connection here because this part you kept open. So you can ignore this particular branch. Okay. Now if you observe these two in that case, these two are connected in series. These two are connected in series, right? So for the time being, I am drawing the part of circuit. Here you are having 18 sin 90 volts. 18 sin 90 volts. Then here these 3 inductors I am considering. Two by 3 Henry, then 1 by 3 Henry, 1 by 3 Henry. Okay, I hope all of you got how I have done the simplification, right? Now these two are connected in. Now these two are connected in series. Okay, just like if 2 resistors are connected in series, we can add the respective resistance. Similarly, regarding inductors also, we can add. Okay, so here you will get regarding the equivalent inductance as 1 by 3 plus 1 by 3. That is nothing but 2 by 3. 2 by 3 Henry. Now you are getting 2 inductors in parallel, right? So and both are having same value. Both are having same value. So in this case, you are going to get the equivalent inductance as 2 by 3 Henry in parallel with same inductance value. You are going to get 1 by 3 Henry. Because both are having same value, equivalent inductance you are going to get half of the earlier value, right? So you are getting simple voltage source. In the previous question, if you observe, you are having one voltage source in parallel with one resistor. In this case, you are having one voltage source in parallel with one simple inductor, right? And that inductor value is 1 by 3 Henry. 1 by 3 Henry. And the current flowing in this particular branch, in the question they have mentioned as I of t. I of t. So, I of t equal to, here supply voltage you are having 18 sin 90 divided by impedance. Okay, here impedance you are having, because it is inductor, j omega L j omega L. J into omega value is 9, L value is 1 by 3. L value is 1 by 3. So here 3 times. Okay. So here 3 6 times. 6 times. Okay. So 6 sine 90. 6 sine 90. Then here denominator you are having j. That means if you want, okay, if you want to represent magnitude and phase, magnitude wise you are having 1. Phase angle wise you are getting 90 degrees. So just bring this phase angle to the numerator, it will become negative. So from here you are going to get I of t equal to 6 sine 90 minus 90 degrees. 6 sine 90 minus 90 degrees, right? So whenever you are having sine or cos, whatever here value you are having, that is the peak value or amplitude, all are same. Okay. So the peak value of the current they have asked. So the answer for this question is 6 ampere. The peak value of the current flowing in the given circuit in this particular branch is 6 ampere. If they are asking RMS value, 6 by root 2, like that. Okay, all of you please respond. Is it clear or not? How many of you felt this is a very interesting question? All of you please respond. Yes, most of you, right? Yes, very good, very good. Now let us see the next question. So in this question, you are having 1 ohm resistor here. In this branch, how much current is flowing? That you have to calculate. So can you mention, for solving this question, which theorem we have to apply? All of you just observe the circuit diagram and guess which theorem we can apply. Yeah, time up. See, just observe the circuit diagram. Here you are having 5 volt source, that is a DC source. You are having inductor, resistor, capacitor, and here you are having 10 cos 2t ampere. Here you are having current source, but it is AC source, right? So whenever you are having in any circuit or network, if you are having the combination of DC source and AC source, or when you are having multiple AC sources, definitely you can solve that question with the help of superposition theorem, right? Okay, so whenever multiple sources are there, you can consider one source at a time. Because of that, you can find the response. Like that, consider all the sources. Okay, whatever the responses, individual responses you are getting, you can perform the resultant sum. Okay, right. So first of all, let us consider DC source first, and then we will consider AC source. Okay. So first I am considering the case only DC source, only DC source. Okay, so here you're having 5 volt source, I kept as it is. After that, now here when we have considered DC source, okay, all of you please respond, whenever we are considering DC source, how the inductor behavior, and similarly capacitor, how we have to represent regarding inductor and capacitor whenever we are considering only DC source. Any guess? So whenever we are considering DC source, that means frequency is what? See, here we are considering 5 volt. That means throughout the time we are having only 5 volt. That means frequency is how much? 0. Correct? Frequency is 0. For all the time instants, we got 5 volt. That means the corresponding frequency is 0. Or we can say whenever you are having DC, t equal to infinity, that means frequency will be 0. Reciprocal of time is frequency, right? So whenever you are having frequency is 0, that means obviously omega value will be 0, because omega is nothing but 2 pi f, right? So regarding inductor, the impedance is what? J omega L. Similarly, regarding the capacitor, the impedance is 1 by j omega c. 1 by j omega c. Now substitute omega value 0 here. So that means here you are getting ZL equal to 0, whereas here ZC you are getting infinity. 1 by 0 means infinity. Okay, you are getting here 0, here infinity. So that means whenever you are getting 0 ohm, that means it is short circuit. Whenever you are getting infinite ohm, that is open circuit. Okay, so whenever you are considering DC source, in the given circuit, if inductor is there, we will replace as short circuit. Inductor becomes short. And similarly, capacitor become open circuit. Capacitor become open circuit. And here in this case, the other source is current source. So we will make current source as open. Okay. Now just observe the circuit diagram. You're having 5 volt across 1 ohm resistor. So that means across 1 ohm resistor, we are getting the supply voltage. The entire supply voltage you're getting across 1 ohm resistor, right? Yeah, Akanksha. Here if you want you can apply KCL, but that is not required. No, that is not required. If you want you can apply, because here terminals are open, there is no current flowing. Here terminals are open, there is no current flowing. Whatever the current here in this branch is flowing, same current is flowing like this. Okay, if you want you can apply, no problem. Here I have considered, because these two branches are kind of in parallel voltage will be same. Okay, your wish, any approach you can follow, no problem. Okay, so here you are having 5 volt and you are having 1 ohm resistor, so you can calculate I of t. So for the time being I am considering I1 of t, because I have considered case 1, right? So I1 of t equal to 5 divided by 1, that is nothing but 5 ampere. Okay, I hope all of you are getting the clarity. When we have considered only DC source, because of that in this 1 ohm resistor, 5 ampere current flows. Now let us do the other case. Okay, in the second case, we are considering the current source, AC source we are considering. Because of this current source, how much current now in this 1 ohm resistor it is flowing. For the time being, since I have considered case 2, this is case 2. Case 2, okay. So in case 2, I am considering the AC source. Because of that, how much current is flowing in this 1 ohm resistor, right? So when we have considered case 2, that time here we are having voltage source, right? It is a voltage source. Okay. Whenever you are having voltage source, we will make it as short. Whenever you are having voltage source, we will make it as short. Okay. The other sources, when you are using superposition theorem, at any time we will consider one source. Whatever the other sources you are having, we have to replace with their internal resistance. If voltage source means short circuit, if current source means open circuit. Okay. Now regarding this particular inductor, the impedance is j omega L. Here in this case, omega value is 2, and L value is 1. So that means you are getting J2 ohm. Okay. Similarly, regarding the capacitor, you can write 1 by j omega c. 1 by j omega c, if you want, you can write 1 by j omega c. Omega value is 2 and capacitor value is 1 by 4. So 1 by j you can write it as minus j, 2 here 2 times. So that means here 1 by 2 you are getting. So when you are bringing this 2 into the numerator, okay, it will become like this. I hope all of you are getting the clarity. Here 1 by j I have written as minus j, and then 2 into 1 by 4 is nothing but 1 by 2. So 1 by 2 is nothing but 2. Right? Now just observe. Here you are having current source, AC source. Okay. We have to find the current flowing in this particular 1 ohm resistor. Now if you carefully observe, you are having current source, you are having capacitor, you are having resistor, you are having inductor. All are connected in parallel only. Right? So whenever elements are connected in parallel, obviously current will get divided. Okay, if you want, you can use current division rule. Okay, right. So for that, you know the standard formula, but that standard formula you can apply for 2 elements, right? So here ultimately you are having one branch where you are supposed to find the current flowing, right? Now whatever the other 2 branches you are having, here looking wise like you are having 2 branches, but initially what you can do, those 2 branches you can make into one branch by finding the equivalent impedance. Okay, so first of all, what I am doing regarding these 2, regarding inductor and capacitor, I am making the equivalent. Okay, so regarding that impedance, say for example, I am labeling as ZA, which is nothing but ZL in parallel to ZC. Okay, first let us calculate this value. So regarding this one, okay, in order to do the simplification, we can use this formula. 1 by Z equivalent is 1 by ZL plus 1 by ZC. Just to do the calculation simpler. Always you can use, whenever you are having inductor capacitor combination or multiple capacitors, better you can use like this formula. Okay. So now regarding inductor, we got 1 by J2. 1 by ZL is nothing but J2. Similarly, regarding ZC, we got minus J2. Okay, 1 by minus J2. Right. So here 1 by J we can write as minus J divided by 2. Minus J divided by 2. Okay. So here if you want, you can multiply and divide with J. Then what will happen? J in the numerator. In the denominator, when you are multiplying with J, J into J is J square, that is nothing but minus 1. Minus into minus is plus. Otherwise 1 by minus J you can write as plus J. Both are same. Now here also, both are magnitude wise same, but polarities wise opposite. So you are getting 0. So whatever 2 branches you are having, inductor and capacitor, after finding the equivalent, here 1 by ZA equal to 0. 1 by ZA you are getting 0. So with this understanding, ZA will be what? Infinite ohm. So whenever you are getting any particular branch, the impedance is infinite, so that means it is open circuit. Infinite ohm is open circuit. Okay, I hope it is clear. Akanksha, is it clear? All other students also please respond. Is it clear up to this point? Here you are having all the elements connected in parallel. You are having one current source. You are supposed to find the current flowing in this particular branch, right? So whatever the other 2 branches we are having, we have calculated the equivalent impedance. So for the time being, we got in this question infinite ohm. So that means it is an open circuit. Okay. So the moment if it is open circuit, obviously as the name implies, open circuit. That means whether any current flows. No, right? Open circuit. The term itself indicates no current flowing, right? Yeah. So that means whatever supply current you are having, the entire supply current is going in the 1 ohm resistor, right? So from here you can write. So here you no need to apply current division rule. Okay. Suppose if you got some finite impedance, then accordingly you could have applied current division rule, but here not required, because the moment you got infinite, it is a open circuit, right? So the entire supply current is going in this 1 ohm resistor. So now you can write I2 of t is equal to the entire supply current, that is 10 cos 2t. Units are amperes. So in case 1 we got 5 ampere. Okay, in case 2 we got 10 cos 2t ampere. In both the cases the current direction is same. If you observe, in both the cases the current direction is same. Whenever current direction is same, we can add the respective currents. Okay, so by using superposition theorem, I of t equal to I1 of t plus I2 of t. In case 1 we got 5 ampere plus in case 2 just now we got 10 cos 2t ampere. Cos 2t ampere. Now you can look at the choices. 5 plus 10 cos 2t ampere. Right, option C is the correct one. Option C is the correct one. Say for example, for this question, okay, if you have considered only case 1, say for example DC voltage source, that time with the help of that one, if you observe the choices, 3 choices satisfying, right? So option D, only one option we can eliminate. But somehow or other for this question, if you have verified with the help of second case, that means with the help of current source, AC current source, then because of that, here you are getting 10 cos 2t, that much current is flowing in this particular 1 moment stop. In this particular question, regarding this particular term, only in one option is there. So whoever attempted this question with the help of second case at the beginning, they can choose the correct option in less time for this question, right? So some of you are asking that, sir, can you share any tricks, okay, for network theory questions? See, whenever MCQ question is there, as the name implies, already the choice is there, right? Multiple choice question, okay. So there is, for solving most of the MCQ questions, there is not only one method, okay. As the name implies, you are having more than one possible method, right? So by following whichever method, you can solve the question easily in less time. Obviously that method is a shortcut, okay. But so whenever you are solving any MCQ question, definitely only one option will be there as a correct. So that means you can follow one approach that systematically you can solve the question step by step conventionally, and from there you can choose among the given choices which one is correct. And the other way of solving or other way of attempting the MCQ questions in the GATE exam is try to eliminate the wrong choice also. Okay, so based on the given question and context, okay, you can follow the first approach or second approach. Say for example here, the moment if you are applying superposition theorem, just observe here, you are having 2 sources, obviously because of this source you will get some response, because of this source you will get some response, right? Now if you observe the choices, from there you are getting the hint, okay, which source you have to consider first time. Say for example here, 5 you are having, like in 3 options it is same, right? 10 only in one option it is differed, okay. So if you want, you can verify that one, okay. With the help of that also you can do partial, all right. So if for this question, whoever tried with the help of 5 volt source, okay, with the help of that one, only one option we can eliminate. But the moment if you have verified with the help of current source, AC current source, okay, in this particular choices regarding 5 cos 2t, you are having 2 choices, minus 5 cos 2t, 1 choice, 10 cos 2t, you are having 1 choice, okay. So in this case, here with respect to AC source, like 2 options are having same response, whereas 2 options are like, the other 2 options are having like different. So broadly speaking, 3 are like different, okay. Out of 4, 3 values are different, whereas regarding DC, out of which, okay, among 4 choices, only 2 values, 2 unique values we are having, right? Okay, so with the, what I mean to say, in some questions you will get the trick like that by observing the choices, whether I have to follow first case or second case. And even one more interesting thing, whenever you are solving any question with the help of first case like DC source, then because you have considered DC, what are the inductor and capacitor you are having, inductor will become short and capacitor will become open. The moment if you are represented like this, the whatever the given circuit you're having, you are getting the simplified circuit, right? So most of the times you can solve these kind of questions whenever you're having DC source, right? You can easily solve without using pen and paper, or whatever the calculation part required, even if at all, try to write the main equation. After that, the calculation part you can do in the mind level, so that you can write the number of steps less, so that in that way also you can make the question solving faster, right? So I hope all of you are getting the clues and hints how to solve the network theory questions in less time. Okay. Now this is a very interesting question. All of you give it a try. This is a very interesting question. So in this question, you're having AC source and source impedance is there and load impedance is there. But in this question, they have given the supply voltage, they have given the source impedance. Now the beauty of this question, regarding ZL, you're having the parallel combination of R and C. Resistor is there, capacitor is there, both are in parallel. That combination is nothing but ZL. Now, in order to get maximum power across this load impedance, you have to consider that condition. You have to consider the condition where you are going to get maximum power across the load impedance. Okay. While considering that condition, okay, after doing whatever the steps are there that you will follow, finally in this particular question, you have to find out the value of R and C. That means just multiply R and C. What is the value you are going to get? See the beauty of this question. They haven't mentioned R value, they haven't mentioned C value. And we are asking in this particular question the product of R and C. But you can get this value even though if you don't know R and C, you will get, because here we have mentioned one condition. In order to get maximum power across load impedance. This is a very beautiful question. All of you give it a try. Yeah, time up. Any guess? Any guess? What is the possible answer? Actually, I kept this question intentionally NIT. Okay, whoever tried sincerely, they only, like whether your answer is correct or not, you might be having some doubt, no issue at all. But after solving this question, what is the answer you are getting, you can mention. And try to mention that answer in the order of millisecond. Okay, whenever you're having RC is nothing but what? Time constant. Obviously, you'll get in the order of seconds. But in this question, I have mentioned milli. So this is one more key point while you're attempting any question in the GATE exam, especially whenever you're having MCQ or MSQ, definitely you'll get the clue, because the moment you're seeing the choices, you'll get the clue. Okay. But whenever you're having NIT, after solving the question, okay, before you're mentioning your answer, just especially after solving any question, if you're having units for that particular parameter, take care about the units. Okay. But generally, most of the students during the exam, they will be in hurry. okay, without seeing the order of the units that they have mentioned in the question, whatever the answer they are getting, directly they will mention. Suppose after solving this question, if you are getting in the order of second, whatever the value you got, you might have mentioned. But here they're asking, if they're mentioning in the order of second, definitely if your answer is correct, then you will get correct marks. Okay, you will get the marks assigned for that question. But if you are mentioning in the order of second, but here requirement is in the order of millisecond, but both are not matching. So definitely, of course, for NIT there is no negative marking, but what are the marks you are supposed to get, you are losing, right? So that's why here in the GATE exam, the most important thing whenever for solving any question, after that, for that particular parameter, if you are having units, just take care about the units. According to the context, the answer will vary, right? That is the most important thing. Okay, so in this question, they have mentioned that in order to get maximum power across the load, okay, so that condition already given. Just observe here, in order to get maximum power across the load impedance, right? So here already source impedance, you know, whenever AC circuit is there, regarding the maximum power transfer condition, in order to get maximum power across the load impedance, I hope all of you are familiar. Can you mention in the chart, what is the condition? In order to get maximum power across the load impedance, ZL should be equal to complex conjugate of source impedance, right? I hope all of you are familiar. Complex conjugate of source impedance. Here source impedance they have mentioned here 50 plus J100. So you have to take complex conjugate. Here you are having A plus JB. Complex conjugate means A minus JB. So in this case you are going to get 50 minus J100. So from here, we can take 50 as common. Just to do the calculation simpler, better take 50 as common. 1 minus J2. Otherwise, you are unnecessarily increasing the calculation part. Okay, right. So 50 into 1 minus J2. So for the timing, now you are having like A minus JB format. Whether you are having A plus JB or A minus JB, whatever you are having, that is in rectangular form. Complex number in the rectangular form. That one you can convert into polar form, R at an angle theta, right? You can represent as magnitude and phase. So from here, regarding this one, magnitude, how much you are going to get? 50 anyway, it is a constant. Magnitude you will get same. Now here you are having A minus JB format, multiply with square root of A square plus B square. Here minus 2 whole square. Okay, minus 2 whole square. So from here, what you are going to get? 50 into square root of 1 plus 4 is nothing but 5. So you are getting magnitude wise root 5, 50 root 5. Okay, and similarly phase angle wise, phase angle. Magnitude of this particular expression you are getting 50 root 5. Okay, and phase angle. Phase angle is nothing but tan inverse imaginary part by real part. Okay, so here imaginary part. In the imaginary part and real part, 50 anyway it is there, so that we can ignore, because when you are mentioning like ratio of imaginary term by real term, okay, in both the terms 50 is there, it will get cancelled. Here if you observe, regarding imaginary part you are going to get minus 2, and regarding real part you are going to get 1. So that means here you are getting tan inverse minus 2. See, if you want you can write like 50 into minus 2 in the numerator, 50 into 1 in the denominator. After that 50 will get cancelled. Okay, so tan inverse minus 2 we can write as minus tan inverse 2. Minus tan inverse 2. So here you got the load impedance in the form of rectangular form, like A plus JB or A minus JB, whatever it may be. From there I have converted into polar form. Okay, I calculate the magnitude. Okay, I got the value as 50 into root 5. If you want you can do simplification. For the time being I kept like this. Okay, similarly phase angle we got like this. Okay, minus tan inverse 2. Now just observe, in this question regarding ZL they have mentioned the clue. ZL is a parallel combination of resistor and capacitor. You are having one resistor, its value is R, and one capacitor is there, its value is C. That parallel combination is nothing but regarding this ZL, right? So now ZL is nothing but parallel combination of resistor and capacitor. Parallel combination of resistor and capacitor, right? So here, for the time being, I am representing like 1 by ZL equal to 1 by impedance of resistor plus 1 by impedance of capacitor. Okay. So regarding resistor, obviously impedance is R, whereas regarding impedance of capacitor, it is 1 by j omega c. 1 by j omega c, directly I am writing as j omega c. J omega c. Okay. Okay. So from here you will get, in the denominator you will get R. Here you are getting 1 plus j omega RC. 1 plus j omega C. So this is your 1 by ZL. Now take the reciprocal. Take the reciprocal. From there you will get ZL. ZL equal to, if you are reciprocal on both right hand side, you will get R divided by 1 plus j omega RC. I hope it is clear up to this point. Okay. Now here you are having like R by 1 plus j omega RC. Here also we can calculate magnitude and phase. We can calculate magnitude and phase. Okay. So for the time being, I am writing magnitude here. Magnitude of ZL. Numerator anyway you are having R, same. Magnitude wise same. Denominator you are having A plus JB. So square root of A square plus B square is nothing but omega RC whole square. Omega RC whole square. Okay, I hope all of you are getting. Right. So here, as of now, we got magnitude. Now, similarly, let us write the phase angle. Phase angle. So, numerator you are having simply in real part. Okay, whenever you are having real part, the phase angle obviously will be having 0 degrees. Okay, if you are having minus, then 180 degrees, or plus 180 or minus 180. Okay. Now, in the denominator you are having A plus JB format. So, regarding this, the phase angle you are going to get tan inverse imaginary term by real term. Here imaginary term is omega RC divided by real term is 1. Real term is 1. So this is the phase angle. Okay. So now denominator phase angle, if you are bringing to the numerator, it will become negative. So 0 minus this phase angle. So that means we can write minus tan inverse omega RC. Minus tan inverse omega RC. Now just observe, whatever the equation here we got, for the timing I am labeling as 2. Okay. Whatever the equation we got here regarding the phase angle, I am labeling as 1. Okay. Similarly, magnitude wise, here you got 50 root 5. Similarly, here you got the expression. Okay. So if you want, you can equate the respective magnitudes or you can equate the respective phase angles. But for this question, you can easily get the answer by comparing the phase angles. Okay. Because just observe here, minus tan inverse omega RC. Here you are having minus tan inverse 2. So that means minus tan inverse, this part is matching. Here you are having simple value 2. Okay. Here you are having omega RC. Now we can equate both, right? So since 1 and 2 are same, from here we are going to get omega RC equal to 2. Omega RC equal to. Now in the question, we are asking that calculate RC value, product of R and C. That is nothing but 2 by omega. Now some of you might be wondering that, sir, here we are getting in the right hand side omega term, but where is the omega value given? See, already the omega value already given, yes or no? Here you are having 50 sine 500t. So here 500 indicates what? Omega only, right? Omega only. So 2 divided by 500. 2 divided by 500. Okay. Now, here 2 how many times? 250 times. Okay, if you are doing simplification, you will get in the order of second. But in the question they are asking in the order of millisecond. So what you can do, whatever the value here you got, multiply and divide with 1000. Multiply and divide with 1000. Here 250 4 times. 1 by 1000 we can write as milli. So that means here you are going to get 4 milliseconds. See the beauty of this question. It is very interesting, right? So all of you please mention how many of you felt this question as interesting. in this entire session, we are discussing most of the interesting questions, logical questions, right? I hope all of you are getting very much interest while solving these questions. Definitely all these questions, whatever we have discussed, right? So all of you are getting benefited from this series, right? Okay, all of you can share your experience. Whoever watching this particular lecture currently in the live, you can mention your experience in the chat, okay? And whoever watching this lecture later, okay? So all of you can share your experience in the comment section, okay? Right. So the final value for this question regarding RC is 4 millisecond. So already they have mentioned in the order of millisecond, it is a NIT question. So answer will be 4. So the final answer for this question is 4. 4. Yeah, all of you give a try. Just just read the question and try to identify this question belongs to which concept. All of you can guess. Already the hint is already mentioned. Just read the question once and identify the concept. This question belongs to which concept? Yes, all of you can guess, right? Here you're having that keyword. It is the resonance. It is the resonance. Okay. And here if you observe this word, series RLC circuit, right? So that means this question based on series RLC circuit. Okay. In this question, we have provided R value, L value, C value, and we are asking to calculate the magnitude of voltage across inductor. Okay. And we have provided the magnitude of source voltage also. Just quickly go through the basic formulas regarding series RLC, and all of you, I am expecting that all of you can give the correct answer. I hope all of you can give the correct answer. Just you should remember the basic formulas. Once if you are good at the basic formulas of series resonance, okay, you can easily attempt this question. Yeah, time up. Whatever the answer you are getting, you can mention the chart. See here we are supposed to find the voltage across inductor, the magnitude of voltage across inductor. Okay, so the magnitude of voltage across inductor we have to find out. So that means here I am representing like this. Okay. Whenever you are having resistor, inductor, capacitor, whatever it may be, okay, in general, we can use Ohm's law. But only the difference, whenever inductor, capacitor is there, we will introduce the term impedance, that's all. Okay. So, voltage across inductor equal to current I into impedance. Impedance magnitude when you have considered, from there we are going to get the reactive component. Okay, reactive component. So, here I is nothing but in the series RLC circuit at resonance, the voltage across the inductor and voltage across the capacitor magnitude wise both are same, and phase angle wise 180 degrees opposite, right? So the net resultant voltage across the combination of inductor and capacitor you are going to get 0. Because of that, whatever supply voltage you are having, the entire supply voltage you are going to get across the resistor, right? So here I equal to Vs by R, where XL is nothing but omega naught into L. In general, we'll write like omega L, but here it is a resonant circuit. That's why I have considered resonant frequency. Okay. Now, Here omega naught you can substitute omega naught equal to 1 by root LC. Here numerator you are having L, right? So this numerator L we can write it as root L into root L. Root L into root L is nothing but root L whole square. Square and root both will get cancelled. You are getting L. Okay. So from here 1 root L we get cancelled. Okay. So from there we are going to get magnitude of voltage across inductor as here numerator you are having Vs divided by R into root L divided by root C. Okay. Root L by C. Root L by C. Okay, here for understanding purpose, I have discussed this one. Okay, but some of you might have remembered the voltage across inductor is nothing but Q times V, Q times supply voltage. Here omega naught L by R is nothing but Q, right? That is nothing but Q. Q times Vs. Okay, so if you want, I am giving the shortcut formula. Regarding magnitude of voltage across inductor is nothing but Q times supply voltage, where Q equal to omega naught L by R. Okay, so for the timing, if you want omega naught L, you can represent as XL. That is the reactive component of inductance. Okay, similarly, you can write this one as 1 by omega naught CR, where 1 by omega naught C is nothing but reactive component of capacitor, that is XC divided by R. So in simple words, you can remember regarding quality factor like this. Denominator you are getting resistor, whereas in the numerator you can consider either corresponding to inductor or corresponding to capacitor. So reactive component of inductor or reactive component of capacitor, right? So XL is nothing but omega L, where XC is nothing but 1 by omega C. Now regarding omega naught, either in this expression or in this expression, if you are substituting 1 by root LC, after that you are going to get the formula like this: 1 by R into root L by C. Okay, 1 by R into root L by C. Okay, if you are able to remember directly one step. Okay, due to any reason if you forget, you can derive the formula by doing some simple steps like this. Okay, no worry at all. Okay, but I am giving the hint. Whenever you are having series resonance, R is in the denominator. In all the formulas, R is in the denominator. Regarding the numerator, XL or XC. Correct? Now if you observe, regarding this L by C, how to write? I am giving the hint. Here L is in the numerator, here C is in the denominator, but only the difference here you are getting root term. Because when you are substituting omega naught, you are having the formula 1 by root LC. Because of that, you are getting the root term. Okay, right. Now you can substitute all the values that they have given on the right hand side. Regarding Vs 40, regarding resistor value 5, regarding inductor L value 1 millihenry, that is nothing but 10 power minus 3, and capacitor value 0.4 microfarad. Okay, 0.4 micro is nothing but 10 power minus 6. This is a direct question, but only the difference. Okay, while solving this question, you have to adjust whatever the powers here you're having. You can do entire calculation without using calculator. Okay, right. So here 5, 8 times. Here 10 power minus 3, 10 power minus 6. So that means you are going to get in the denominator 1 by, here 10 power minus 3 you are getting. Okay, here 0.4 we can write as 4 into 10 power minus 1. 4 into 10 power minus 1. Okay, now 8 I am keeping as it is in the denominator, root 4. Okay, see this entire part is in the denominator only, right? So root 4 is nothing but 2. 10 power minus 1 into 10 power minus 3. 10 power minus 1 into 10 power minus 3, that is nothing but 10 power minus 4. Root 10 power minus 4 is nothing but 10 power minus 2. 10 power minus 2. Here 2, 4 times. 10 power minus 2 if you bring to the numerator, it will become positive. 10 square, right? 10 square is nothing but 100. So that means directly I am writing 400. Units are volts. So the voltage across inductor at resonance in the series RL circuit, for this question you are getting 400 volts. Okay, I hope it is clear for everyone, right? Now let us see the last question regarding network theory subject in this gate score booster series. This is a question based on two-port networks. So all of you just observe the circuit diagram. For this question, I am not putting any timer because this question is direct question and simple question. Just observe the circuit diagram given two-port network and just tell me how these two, see this is one two-port network, this is another two-port network, how these two two-port networks are connected. Once if you are able to identify, after that this question is nothing. Okay, that is the hint point. In general, we will frame that wording in the question itself, but instead of giving the direct wording, here I have represent the two two-port networks I have connected like this. Can you guess? Once if you are able to guess, after that you can solve this question easily. See here, see, forget about this two-port network. When you are having only this two-port network, okay, this is port 1, port 1. Here I1 current is entering like this, that means same current will leave from this another terminal in the port 1. Similarly, when you are having second port, here if I2 current is entering, the same current will leave. For any network, if some current is entering, the same current should leave. Okay. Similarly, here I2 current is entering, I2 current is leaving. Now just if you observe, for this two-port network, the input current is nothing but this current. Right, if I1 current enters like this, same current will leave. Similarly, for this two-port network, okay, the input current is nothing but the output of this two-port network. So that is nothing but here I2, and the same current will leave like this. Now, at least can you identify now? Yes, very good. These two two-port networks are connected in series, right? So that is the hint point. Whenever two-port networks are connected in series, whatever the impedance parameters we are having, we can add the respective impedances. Just like when you are having two resistors, or two inductors, or two capacitors, or maybe combination of resistor and inductor, or resistor capacitor, or inductor capacitor, etc. Whenever two branches which are connected in series, we can add the respective impedances in the similar way. Whenever two two-port networks are connected in series, we can add the respective impedances, right? We can add the respective impedances. So here in this case, we can add the respective impedances. So here we are going to get ZA plus ZB. ZA plus ZB. So just you can add the respective impedances. Okay, so first I am representing ZA matrix, that is 3, 4, 3, 9. Similarly, ZB as 9, 7, 6, 2. 9, 7, 6, 2. Okay, I hope all of you are very much comfortable regarding addition of matrices or subtraction, right? So you can add the respective row wise and column wise, whatever the elements you are having, you can add the respective elements. Okay, 3 plus 9, that is 12. 4 plus 7, 11. 3 plus 6, 9. 9 plus 2, 11. So this is the resultant matrix you got regarding impedance parameters. Now, just one second. Okay. Regarding this particular matrix, whatever the Z parameter matrix you got, for that we have to calculate the determinant of overall Z parameters matrix, right? So for this matrix, we have to calculate the determinant. In general, whenever you are having impedance matrix, all the units are in the order of ohm. Okay. Now we have to perform the determinant. Okay. We have to do the multiplication of these two, and then we will multiply these two. From the first product, we will subtract the second product, like AD minus BC. Okay. So determinant of resultant Z matrix is nothing but 12 into 11 minus 9 into 11. 9 into 11. So from these two, if you observe, okay, if you want, you can do simplification here, you can do simplification here, after that you can do simplification, but unnecessarily you are increasing the calculation, right? But just if you observe these two terms, you can take 11 as common. So from there you are going to get 12 minus 9. 12 minus 9 is nothing but 3, right? So 11 into 3. that is nothing but 33. Since here you are multiplying 2 ohms, right? Ohm into ohm is nothing but ohm square. That is the reason here we have mentioned units are ohm square. Okay, right. So the final answer for this question is 33. Okay, so I hope all of you got the clarity, right? Yeah, in this session and previous session together, we have discussed variety of interesting questions. In the previous session, we have mostly dedicated on the first chapter, and regarding second chapter, we have discussed only one question, that is regarding superposition theorem. Whoever missed the earlier session, no worry at all. In your free time, try to watch that session. Okay, so you will get good comment over the first chapter and regarding second chapter regarding superposition theorem. Whereas in this particular session, we have discussed variety of interesting questions regarding maximum power transfer theorem, and regarding transients we have discussed 2 interesting questions, right? One question we have discussed source free circuit after switching action, whereas another question we have discussed after switching action with the sources, right? Okay, so how to find the initial condition, how to find the time constant, or how to find the voltage expression or current expression, etc. we have discussed. With respect to RC, we have discussed similar procedure for RL circuit as well. After that, we have discussed variety of interesting questions regarding steady state analysis. So regarding steady state, we have discussed the basic questions with the help of simplification of equivalent networks. Okay. Ultimately, I asked in those questions either current or voltage or power, etc. Okay, across a particular branch. But whatever the network I have provided, so those networks I have made in the logical manner, because in general some of the students while solving these questions they may apply star to delta, delta to star, but most interesting thing you got without applying star to delta, delta to star, by using series and parallel connection we have done the simplification, right? After that we have discussed variety of questions regarding resonance concept and superposition theorem also we have covered, maximum power transfer theorem also we have discussed, interesting question, right? And then we have discussed regarding 2-port networks, one of the interesting question regarding 2-port networks regarding the series configuration, right? So in this way, in the previous session and this session together, we have discussed good number of interesting questions through which we have covered the most expected concepts and the methods of solving network theory questions. Based on the possibility, I have discussed the question in the conventional approach or regular method. After that, I have discussed the shortcut method also, right? And wherever possible, I have highlighted where in general the students will do the silly mistakes, right? So all these are learnings for all of you, whoever the students, whoever writing the GATE exam in EC branch, electrical branch, instrumentation branch, definitely this subject is having the more or less equal weightage in all 3 branches, right? Around 8 marks you used to get directly from network theory subject, and indirectly it is helping, right, in your analog circuit subject, etc., in other core subjects. So that much importance is there for this network theory subject. So all of you kindly go through, whoever missed either previous session or this session due to any reason. Okay, so kindly watch these 2 sessions thoroughly. Definitely it is going to give great value addition in your coming GATE exam, right? So what are the concepts and methods you have learned, right? So try to revise or practice once again in your free time, right? So definitely you'll get good command over the network theory subject. Once if you're confident in network theory subject, definitely you can attempt the analog circuit subject questions or electrical machines or power electronics, etc. Whoever from EC, they can easily attempt analog circuit. Similarly, electrical students, they can attempt analog circuit questions or electrical machine, power electronics, etc. Okay, right. So all of you kindly share this video link and the previous link with all of your friends, and whoever targeting for the coming GATE exam, definitely they will get benefited, right? And whoever targeting for GATE 2025 or 2026, okay, so I am just announcing at our IMS GATE Academy, we are providing the live online program for both GATE 2025 and 2026. Whoever targeting in these 2 years, we are providing live online program. So here you will get 800 plus hours of live classes. Okay. So here all our faculties will discuss each and every concept from the basic level to the advanced level, application level, etc. And we will discuss each and every concept first, and in order to get good command over the concept and in order to get crystal clear understanding about each and every concept, we will discuss the variety of questions from the basic level to the application level, so that each and every student whoever attending our classes, they will get good command over the concepts, and not only that, they will get good command over the methods of solving, right? So that is the most interesting thing, right? And in addition to that, we are going to provide for every subject theory book, exercise book, right? We are going to provide. So in the exercise book, we are providing 3 levels of questions, like level 1, level 2, level 3. So all our students, they can practice all the questions. Okay, in every chapter, we are going to provide around 60 questions. Okay. So all the students, they can practice all these questions. They will get good command over the subject. Okay. And here we are providing gate question bank. In that gate question bank, we are providing the recent or last 30 years. Okay. And here in this gate question bank, based on the requirement for that particular question, we are providing more than one solution. And what are the important points are there in that question, we are providing. So in that way, you are getting great opportunity while you are solving the questions in our gate question bank. Okay, you are getting good command over the concepts, you are getting good command over method of solving any gate question. Okay, and in addition to that, we are providing more than 130 online tests. Okay, here we will be providing for every subject, you will be having various chapters. For every chapter, we are going to provide one test, and similarly for every subject, we are providing basic level test, advanced level test, and then multi-level test, multi-subject test. Okay, and after that, we are going to provide all India mock tests. Okay, 12 all India mock tests we are going to provide. Together, all these tests together, you are going to have more than 130. Okay, 130 plus online tests. In addition to that, we are going to provide 12 my plan sessions. These are the personalized sessions. Okay, every student, whoever enrolling for our live online program, each and every student, they can book the slot with the corresponding mentor, and they can get the proper guidance and study plan for their gate preparation. Okay, so all of you can share this valuable information with your friends and juniors whoever targeting for gate 25 and 26, and they can book the free counseling session. Regarding that description, this particular link is already provided in the description, or you can directly call to these 2 numbers also. And here, this is our Telegram channel regarding IMS Gate Academy. Regarding our Telegram channel also, link is provided in the description. Whoever not yet joined, so kindly join our Telegram channel. It is free for everyone, right? So if you are joining our Telegram channel, what kind of benefits that you are going to get? Say for example, currently you are attending the series of Gate Score Booster in our YouTube channel, right? Similarly, whatever the upcoming live sessions are there, our faculties will share regarding the upcoming YouTube link and schedules. Okay, our team will share the respect to whatever upcoming YouTube lectures which are coming in the live. Our team will share, and in fact, our faculties also will share whatever the upcoming YouTube links are there. They will share. Okay, in this particular app. Okay, and after explaining whatever the concepts we are discussing during live sessions, whatever we are writing on the digital board, the entire lecture notes we are going to provide in the PDF. Okay, in that live session, whatever we have taught, that lecture PDF we are sharing in this Telegram app. It is free for everyone, right? Okay, so whoever want to refer whatever we have explained here, you can refer. Okay, it will save your time. And in this particular app, we will share whenever we are conducting any seminar or webinar, we will give the update in this particular app, Telegram app, in our channel. And we are going to share regarding PSU and other government job notifications also, we will share in our channel. Okay, and not only that, on daily basis, we will provide one daily quiz question. So all the students whoever in our group, okay, they can actively participate, and the very next day our faculties will provide the solution for that quiz question. So you people can go through, and if you are getting correct answer, that means excellent. Due to any reason, if you are doing wrong answer, or if you are attempting the question wrongly, or if you are stucking, no problem at all. You can go through the solution provided by the faculty, and in that way, you are getting opportunity on daily basis. You are getting something. You are getting opportunity to learn something new, right? Regarding your subjects. Okay. In this way, it is going to help regarding your gate preparation a lot. Okay. So this is all about regarding today's session. So I hope all of you got lot of benefit from these two sessions regarding network theory subject. Similarly, in the upcoming weeks, we are having for other subjects. So kindly just subscribe our YouTube channel, IMS Gate Academy YouTube channel, and click on the bell icon in order to get the instant notification so that you won't miss even single video. Okay, right. Thank you everyone. So we'll meet you all. I will come once again in the live session, okay, in the upcoming week on coming Saturday and Sunday regarding communication system subject, gate score booster, right? So in those sessions, I will discuss regarding communication system subject. So meanwhile, other subjects we will conduct regarding gate score booster sessions by our faculties. So regarding the schedule and all, you can just visit our IMS Gate Academy YouTube channel and just click on the bell icon so that you will get instant notification. Okay, thank you everyone. We'll meet you all in the next session.